Welcome to Azure Infrastructure Management, Storage, Monitoring, and Backup Solutions. By this point, you probably know quite a bit about what it takes to configure, deploy, and manage Azure resources. However, that doesn't mean you've covered everything there is to know about Azure. Another crucial component concerns the services and practices that keep your environment operational and behaving as expected. That's why in this portion of your learning journey, you'll become familiar with the Azure solutions and features that are essential for keeping things running smoothly. To be more specific, you'll broaden your knowledge in 3 areas: monitoring your environment to detect issues that can impact operations or performance, selecting and configuring storage options to meet your organization's needs, and backing up your files and data to enable recovery in case of disaster. This course is designed and built by subject matter and industry experts in the field. It's been created to equip you with theoretical and practical knowledge and real-life problem-solving skills to be successful in an entry-level job. Now let's go over the core topics that you'll cover as you progress through this course. You'll begin with an introduction to the fundamentals of Azure Monitor, including its role in monitoring your Azure infrastructure. You'll explore the solution in context by analyzing real-world case studies to identify practical applications and implementing basic configurations through the Azure portal. The second module is all about Azure Storage, with a focus on the fundamentals of Azure Blob Storage, optimization strategies, and integration with other Azure services. You'll find out how to configure and secure these storage solutions to ensure they meet your organization's needs. You'll also gain some techniques for navigating large data sets with Azure Log Analytics, which is a tool for extracting data from Azure Monitor logs to produce meaningful insights. This includes learning the essentials of Log Analytics query language and practicing by running and analyzing some basic queries. In the third module, you'll explore Azure Backup concepts. This includes learning about essential backup strategies and configuring backup policies for files, folders, and virtual machines. You'll then focus on security and stability within Azure with an introduction to patching and updating, which are critical practices for keeping your virtual machines safe and problem-free. Finally, you'll conclude this course with a final project and graded assessment. This project will require you to apply your knowledge to design a secure and compliant Azure infrastructure that aligns with specific business needs. The graded assessment will then test your understanding of the full scope of Azure Storage, Monitoring, and Backup solutions covered in the course. In addition to getting you closer to mastery of Microsoft Azure, there is something else to gain by completing this course. It will leave you better prepared for the AZ-900 Microsoft Azure Fundamental Certification exam. Successful completion of this exam provides proof of your Azure expertise and job readiness and plays a valuable role in advancing your IT career. So, now that you know what to expect, let's get started and take your Azure knowledge to new heights.
Picture this. Your organization has migrated its infrastructure to the cloud and is ready to continue business. However, issues soon start coming up. Numerous traffic bottlenecks in the network hinder access to crucial resources. The IT team is diverted from other tasks in trying to remove these hurdles, and overall productivity slows to a standstill. So, what can the team do to mitigate network slowdowns before they progress into full-on blockages? They'll be glad to know that a powerful solution is available in the form of Azure Monitor, Microsoft's comprehensive monitoring service for Azure environments. In this video, you'll explore the role and components of this tool and find out how it collects data. Azure Monitor provides full-stack monitoring across your Azure resources and applications. Think of it as the central nervous system for gathering telemetry, metrics, and logs from various components of your system, enabling you to monitor their health, performance, and availability. Azure Monitor collects and aggregates the data from every layer and component of your system across multiple Azure and non-Azure subscriptions and tenants. It stores it in a common data platform for consumption by a common set of tools that can correlate, analyze, visualize, and/or respond to the data. You can also integrate other Microsoft and non-Microsoft tools. In an Azure environment, everything from virtual machines to databases generates telemetry data. Azure Monitor collects and consolidates this data, providing a unified view of the overall health of your environment. To break this down, let's unpack the core components of Azure Monitor, which are metrics, logs, alerts, and application insights. Metrics are numerical values that describe the performance of resources over time. These could include CPU usage, memory utilization, network traffic, and more. For example, you can track how much memory a virtual machine is using and set up an alert if it exceeds a certain threshold. Metrics are typically used for real-time monitoring and quick visual analysis through dashboards. Logs are detailed, time-stamped data files that provide insight into operations happening on your resources. Azure Monitor logs use Log Analytics, which allows you to query and analyze the logs across your Azure resources. For instance, logs might capture every HTTP request made to your web application or track detailed diagnostic information about failed requests. Alerts allow you to proactively monitor your system by notifying you when a condition is met based on metrics or logs. These could be email notifications, SMS alerts, or even automated actions like scaling up resources. For example, if the CPU usage of your web server consistently exceeds 80%, Azure Monitor can trigger an alert to automatically scale up additional servers. Application Insights is a specialized service within Azure Monitor designed to monitor the performance of your applications. It provides deep insights into application behavior, including response times, error rates, and dependency failures. It also tracks user activities, so you can see which parts of your application are used most frequently or are causing problems. When you deploy any resource in Azure, whether it's a virtual machine, a database, or a web app, Azure automatically starts collecting telemetry data from these resources. This data can be accessed through different channels, like the Azure Monitor Metrics Explorer for real-time insights or Azure Monitor Logs for deeper analysis using Kusto Query Language, or KQL. Now that you have a fundamental understanding of what Azure Monitor can do, let's examine how it might be used in a few real-world scenarios. Let's say you've deployed a virtual machine that's running a business-critical application. To ensure smooth performance, you need to monitor its CPU, disk space, and network traffic. In this case, metrics allow you to track the CPU usage and alert you if it exceeds a predefined limit, while logs can provide detailed data about specific processes running on the virtual machine, such as failed security logins or application crashes. Alerts can be configured to automatically scale the resources or send notifications to the operations team. In this way, Azure Monitor ensures your virtual machine is constantly monitored and issues can be addressed proactively. In another scenario, let's say you're running a web-based application on Azure App Service. To ensure it's running optimally, you need to monitor the HTTP request rates, error responses, and page load times. Here, Application Insights allows you to monitor the performance of your application at the code level, giving you detailed telemetry like which API endpoints are slow or failing. You can set up alerts to notify you if a certain API call takes longer than expected or if there's a spike in server-side errors. And logs help in troubleshooting issues by showing detailed information about requests, dependencies, and exceptions. With Azure Monitor, you can not only monitor, but also optimize your application's performance by identifying bottlenecks and failures early. When it comes to data collection, Azure Monitor integrates with nearly every resource in Azure. It supports various data sources, including Azure services like Azure Kubernetes Service, or AKS, Azure SQL Database, and others. On-premises resources using agents like the Azure Monitor agent to ensure that Azure Monitor isn't limited to just the cloud. And custom applications from which you can send telemetry data directly to Azure Monitor using SDKs for .NET, Java, Node.js, and more. Now, let's wrap up with some of the benefits that you stand to gain by integrating Azure Monitor into your toolset. One is proactive monitoring, as instead of waiting for users to report problems, you can set up proactive monitoring and receive alerts when issues are detected. Another is end-to-end visibility. Azure Monitor provides full visibility into your entire infrastructure and applications, from the virtual machines running your services to the user interactions with your apps. And then you have automation. Azure Monitor's tight integration with Azure Logic Apps and automation allows you to automatically trigger actions in response to alerts, reducing manual intervention. In this video, you discovered the role and key components of Azure Monitor, as well as how it collects data. You now know why it is an essential tool for maintaining the health, performance, and security of your Azure resources. It provides the visibility you need to ensure your applications and infrastructure are running smoothly, and offers powerful tools to diagnose issues, prevent downtime, and maintain optimal performance. Recently, you were made aware of Azure Monitor and the core components that make it an invaluable tool for tracking resource health and performance. But do you understand the true impact of using the solution in the real world? In this video, you'll discover exactly that as you explore several scenarios that call for the use of Azure Monitor's advanced features. This will help you to understand how to extend the platform's capabilities to monitor more complex environments and use cases, including custom monitoring setups and integrations. Basic monitoring, like tracking CPU usage on virtual machines, works well for many scenarios. However, as your environment grows in complexity, you'll need more sophisticated monitoring approaches. Azure Monitor provides advanced capabilities to handle this, such as custom metrics and logs from your applications, custom log queries from deep dive analysis, advanced alerting mechanisms, and automation of remediation actions using integration with Azure Logic Apps or Azure Automation. With these features in mind, let's examine a few advanced scenarios where Azure Monitor truly shines. Distributed applications like those built using microservices architecture have multiple components spread across different environments. This can include virtual machines, containers, databases, and APIs, all running independently but working together to deliver a service. Monitoring such an environment is more challenging compared to a single resource, but Azure Monitor can prepare you to handle it. For one, it enables you to define and collect custom metrics from your application and infrastructure. You can track any metric that is relevant to your business, such as the number of user transactions processed, application response times, or the success rate of API calls. When your application spans multiple services, it's crucial to track the dependencies between those services. With Application Insights, Azure Monitor automatically maps out service dependencies, helping you trace the source of performance issues. For example, if a web application is slow due to a database call, dependency tracking will show you where the bottleneck is. You can also set up custom log queries to correlate metrics and logs from various parts of your application. For instance, you can query logs from your web front-end, back-end APIs, and database in one go, helping you identify how performance issues in one part affect the overall system. Another helpful capability that helps with distributed applications is advanced alerting. In a complex distributed system, alerting based on simple thresholds like CPU usage may not be sufficient. Azure Monitor allows you to create multi-condition alerts that only trigger when multiple conditions are met. For instance, you can set an alert that triggers if the average response time of a microservice exceeds a specific threshold and if the error rate of dependent services increases. Such composite alerts help reduce unnecessary or irrelevant notifications, often referred to as noise, ensuring you're only alerted about critical issues that impact the end user experience. Let's explore another situation where Azure Monitor proves its value. Consider an organization that favors a proactive rather than reactive approach to issue resolution. To achieve this, they'll need to identify and rectify anomalies before they evolve into real problems. Fortunately, Azure Monitor supports proactive monitoring using machine learning-based insights. This can help detect or predict issues before they occur, allowing you to address problems early and reduce downtime. There are several key features that define proactive monitoring in Azure Monitor. One is anomaly detection. Azure Monitor uses machine learning algorithms to automatically detect anomalies in your metrics. An example of this is if your application typically processes 1,000 transactions per hour and suddenly drops to 500, which Azure Monitor flags as an anomaly and triggers an alert. You can apply anomaly detection on various metrics, such as network traffic, CPU usage, or application response time, helping you spot unusual behavior that may not immediately trigger a traditional alert. Another feature is performance forecasting. Azure Monitor can use historical data to forecast future trends. For example, it can predict when your database's storage capacity will run out based on current usage trends. This allows you to take action before a problem arises, such as increasing storage capacity or optimizing resource usage. And then there's Smart Detection, a feature of Application Insights that automatically identifies performance degradation in your application based on historical problems. It uses machine learning to analyze telemetry data and notifies you when something abnormal is detected, such as a sudden increase in response times or error rates. Let's explore one more scenario that demonstrates where Azure Monitor can make an impact. Let's say that the primary headache with your company's application isn't locating issues, but rather the time and effort it takes to deal with them. The company will be glad to know that beyond monitoring and alerting, Azure Monitor integrates with Azure Logic Apps and Azure Automation to allow for automated remediation of issues. This enables self-healing infrastructure that can respond to problems without manual intervention. One example of automated remediation in action is automatic resource scaling. If your application experiences a sudden spike in traffic, Azure Monitor can trigger a Logic app to automatically scale your resources. For instance, it could increase the number of virtual machines or scale up the performance tier of a database when CPU utilization reaches a certain level. Another use is for restarting services. If Azure Monitor detects that a service has become unresponsive, it can automatically trigger a remediation action to restart the service or virtual machine. This ensures minimal downtime and faster recovery from service failures. And one more example concerns integration with IT service management, or ITSM systems, like ServiceNow or Jira. When an alert is triggered, Azure Monitor can automatically create an incident in your ITSM system, assign it to the appropriate team, and track its resolution. In this video, you discovered that Azure Monitor is not just about basic telemetry and alerting. By leveraging advanced capabilities like custom metrics, cross-resource correlation, machine learning-based anomaly detection, and automated remediation, you can build a highly sophisticated monitoring solution tailored to your specific environment and needs. Whether you're managing a complex distributed application, monitoring non-Azure resources, or looking to proactively address issues before they escalate, Azure Monitor provides the tools you need to ensure the performance, availability, and security of your infrastructure. By now, you're no doubt aware that Azure Monitor gives you a comprehensive view of resources and applications in your Azure environment. But broad coverage is only part of the equation. How useful is this solution when it comes to covering granular details? Thanks to the high interoperability of the Azure ecosystem, you've got nothing to worry about. In this video, you'll become familiar with Azure Application Insights, a service that integrates seamlessly with Azure Monitor to provide deep insights into your applications. This tool is an Application Performance Management, or APM service designed to monitor live applications. It helps you detect performance issues, diagnose problems, and understand how users interact with your application. While Azure Monitor focuses on infrastructure and resource level monitoring, Application Insights zooms in on the application layer, providing detailed telemetry about how your application performs. Let's preview some of the tools within Application Insights that help you enhance the performance, reliability, and quality of your applications. One is the Application Dashboard, which provides an at-a-glance assessment of your application's health and performance. You can access the Application Dashboard by first selecting Overview in the navigation panel of Application Insights, followed by Application Dashboard at the top of the Overview page. This example features several graphs that visually show server requests, response times, and failures over the previous hour. Dashboards can be deeply customized by setting timeframes, filters, and the frequency at which the data is refreshed. Another useful view is the Application Map, which is found under Investigate in the navigation pane. This provides a visual overview of application architecture and components interactions. For example, Let's say that in addition to understanding the overall performance of an application, you also want an update on its individual components. With the application map, you can check all of this on the same page. And one more tool of note is Live Metrics, a real-time analytics dashboard for insight into application activity and performance. This allows you to track various application metrics live, which is useful for quickly validating updates or fixes. Now, let's go over the key features of application insights that give you an edge over using Azure Monitor alone. One is request tracking. Application Insights tracks every HTTP request made to your application, allowing you to see how requests flow through various services and pinpoint where bottlenecks occur. Another is Performance Metrics. This provides a detailed view of application performance, including server response times, memory usage, and dependency tracking. Then there are User Behavior Analytics. Application Insights also tracks user interactions, showing you how users navigate through your application, which pages are most popular, and where users experience errors or drop-offs. Finally, you have Error Tracking. One of the key features of Application Insights is its ability to track exceptions and errors in real time. It provides detailed diagnostics for every exception, helping you understand where failures are happening in your code. Okay, so now that you know what makes Application Insights such a useful tool, let's talk about how it integrates with Azure Monitor. Application Insights is built on top of Azure Monitor, meaning all the telemetry it collects is integrated with Azure Monitor's capabilities, like Log Analytics and alerting. This enables several functionalities. For one, it achieves unified monitoring. This means that whether you're tracking infrastructure health or application performance, all your telemetry data flows through Azure Monitor. You can view both infrastructure metrics like CPU usage and application-specific metrics, such as response times, side by side. Another ability is custom queries. You can use Log Analytics to query telemetry data collected by Application Insights, such as filtering logs to identify the root cause of application errors or correlating application-level data with infrastructure metrics. There is also advanced alerting, such as setting up alerts based on application performance metrics. For example, you can trigger alerts when response times exceed a threshold or when error rates spike, allowing you to react quickly to performance issues. To put everything together and find out how it all works, let's analyze a scenario that shows Application Insights in action. Imagine you're running a web-based application hosted on Azure. Performance hasn't been as fast or consistent as expected, and you're not sure why. With Azure Application Insights, you have the means to locate and respond to any potential causes. For example, you can track user interactions, understanding which parts of your application are most used and where users experience performance issues. You can also monitor HTTP request performance, which helps with identifying slow requests or failed responses. And then there's the option of setting up alerts to automatically notify you if response times exceed acceptable levels or if there's a significant increase in error rates. In this video, you discovered that by integrating Application Insights with Azure Monitor, you can extend your monitoring capabilities beyond just infrastructure and get a full view of how your application is performing and how users are interacting with it. This solution provides powerful tools to monitor and optimize the performance of your applications, and combining it with Azure Monitor creates a unified monitoring environment that covers both infrastructure and application layers. As you recently discovered, Azure Monitor provides a comprehensive view of the infrastructure of your Azure environment, while Azure Application Insights sheds light on what happens at the application level. However, consider a business that has complex monitoring needs and requires collection of precise log data under very specific conditions. Where basic configurations aren't quite enough, these tools have more functionality to offer. In this video, you'll explore advanced monitoring techniques with Azure Monitor. These techniques will allow you to customize your monitoring approach to better suit complex environments and unique operational requirements. Azure Monitor's advanced features enable you to go beyond basic telemetry and predefined alerts, giving you the flexibility to create custom logs, sophisticated alerts, and targeted insights. These features are especially useful in large, distributed systems or when dealing with unique business metrics and conditions. So let's go over some techniques for utilizing these features and examine some situations where they might be useful. One technique is custom logging. While Azure Monitor automatically collects logs and metrics from Azure services, custom logs allow you to collect and analyze unique data points or events that are not part of the default logging. Imagine you are monitoring a financial application that processes transactions. In addition to basic metrics like CPU usage and response time, you want to track custom events such as failed transaction counts, transaction latency, or payment gateway errors. You can log these events using custom logging mechanisms, allowing Azure Monitor to track and analyze them alongside standard logs. To apply this strategy, use Azure Monitor logs to create custom logs by sending data directly to the Log Analytics workspace through APIs or SDKs. Once the data is collected, you can query it using Kusto Query Language or KQL and build custom dashboards to visualize it. Another technique is logging queries for complex analysis. Azure Monitor's Log Analytics is powered by KQL, which allows you to write powerful and flexible queries to analyze your logs. This is particularly useful when you're trying to identify trends, correlate events across services, or troubleshoot complex issues. Suppose your web application is seeing an increase in failed API requests, and you want to determine if these failures are related to specific regions or dependent services. Using a KQL query, you can correlate the API errors with geographical regions, network latency, and database performance metrics to uncover the root cause of the problem. To log queries in the Azure portal, navigate to Log Analytics and use KQL to write queries that filter, sort, and aggregate log data. You can create dashboards or set up alerts based on query results. Another trick to keep in mind is that Azure Monitor supports the creation of multi-condition alerts that trigger when multiple metrics or log conditions are met. This is ideal when you want to fine-tune your alerts to reduce noise or only trigger notifications under very specific conditions. For example, you're monitoring an e-commerce platform and you want to be alerted when both page load times and shopping cart abandonment rates increase beyond normal thresholds. By setting a multi-condition alert, you can ensure that only critical performance issues are flagged, reducing unnecessary alerts. Additionally, Azure Monitor can automatically adjust alert thresholds using dynamic baselines. This means that instead of setting a fixed CPU usage limit like 80%, Azure Monitor can learn typical patterns over time and trigger alerts only when usage deviates significantly from normal behavior. One more technique to know about is proactive monitoring with insights. Azure Monitor's Insights feature provides pre-built monitoring solutions for specific resources like Azure SQL Database, Azure Kubernetes Service, or AKS, and virtual machines. These insights offer tailored metrics, dashboards, and alerts based on best practices. If you're managing a containerized application using AKS, you can leverage AKS Insights to monitor your cluster's performance, track pod and node health, and view metrics such as CPU or memory usage at both the cluster and pod levels. Enabling Insights is straightforward. Simply select the resource type, such as Azure SQL Database, and activate Insights from the Azure Monitor dashboard. From there, you'll get pre-built dashboards and alerts for optimal monitoring. Before wrapping up, let's analyze a scenario that calls for leveraging a combination of these advanced techniques. Imagine you're managing a large-scale e-commerce application with multiple microservices, hosted across Azure VMs, AKS, and Azure SQL Database. To monitor this complex setup, you can use custom logging to track failed orders, log queries to correlate API performance with database query times, and set multi-condition alerts to notify you when page load times and cart abandonment rates spike simultaneously. On top of that, you can use Insights for deeper monitoring of your SQL database and AKS clusters. This approach gives you a comprehensive monitoring solution that is both flexible and proactive, allowing you to quickly identify, analyze, and resolve issues. In this video, you learned how Azure Monitor's advanced monitoring techniques allowed you to customize and fine-tune your monitoring strategy to handle more complex scenarios. Whether you're using custom logs, multi-condition alerts, or dynamic thresholds, these features provide the flexibility and depth needed to ensure the smooth operation of your applications and infrastructure. By now, you should have a solid understanding of key Azure Monitor components, such as using metrics, alerts, and log monitoring to maintain the health, performance, and security of your Azure resources. With this foundation in place, it's time to explore the broader set of features Azure Monitor offers that will take your monitoring capabilities to the next level. In this video, you'll discover unified monitoring, application insights and log analytics, Azure Monitor for containers and virtual machines, or VMs, alerts and action groups, and service health monitoring. Azure Monitor is much more than just a tool for tracking metrics or logs individually. It's a unified monitoring solution designed to provide full visibility across all your resources. From infrastructure and networks to applications and users, this unified approach enables you to correlate data across various components within your Azure ecosystem, offering a comprehensive view of your workloads. Key aspects of this unified monitoring include cross-resource correlation, allowing you to analyze metrics and logs across services such as VMs, databases, and Kubernetes clusters. It also lets you monitor both Azure native and non-Azure resources, including on-premises systems. This means no matter where your infrastructure resides, you have the insights needed for proactive management. Now, moving on to two of the most powerful features in Azure Monitor, application insights and log analytics. These tools provide in-depth visibility and actionable insights into your applications and infrastructure. Application Insights focuses on providing visibility into the application's performance by capturing application-specific metrics such as response times, exceptions, and dependency tracking. This feature helps you monitor user behavior and usage patterns, both crucial for application performance tuning. On the other hand, Log Analytics enables advanced log querying using Kusto Query Language, or KQL, to extract insights from logs and telemetry data across all your resources. You can then use custom dashboards and reports to present real-time analytics from the collected data, providing actionable insights into system operations. Together, Application Insights and Log Analytics offer detailed performance data and help you diagnose the root cause of any issues that arise. Consider a scenario where you want to track the performance of a web application under varying load conditions. Application Insights would help you monitor user interactions, identify performance bottlenecks, and detect slow API responses. Meanwhile, Log Analytics allows you to run detailed queries to correlate logs across various resources, such as your web server and database, to uncover the root cause of performance issues. This combined approach allows you to pinpoint areas where users encounter delays, enabling you to optimize your application and enhance the user experience. What's more, Azure Monitor extends its capabilities to containerized environments and VMs, providing specialized tools for monitoring these resources. Azure Monitor for Containers is designed to monitor Kubernetes clusters, whether they are running in Azure Kubernetes Service, or AKS, or non-Azure Kubernetes environments. It offers insights into pod and node performance, tracking key metrics like CPU and memory usage. These insights help ensure that your containerized applications remain healthy and scalable. Azure Monitor for Virtual Machines collects and analyzes performance data from VMs. It delivers detailed insights into key performance indicators such as disk performance, memory usage, and network traffic. Additionally, guest-level metrics within VMs can be monitored to ensure optimal operation within your cloud infrastructure. These features empower you to maintain the health and performance of both containerized workloads and VMs across your Azure environment. Azure Monitor also provides advanced alerting features with dynamic thresholds and action groups. Using machine learning-based insights, Azure Monitor can automatically adjust thresholds based on historical data. This means that instead of setting static thresholds, for example, alerting when CPU usage exceeds 80%, Azure Monitor will alert you only if performance significantly deviates from normal patterns. Going beyond just notifications, alerts can also be configured to trigger actions, such as running Azure Automation, Logic apps, or sending notifications to external systems via webhooks. You can use action groups to configure a set of actions that can be shared across multiple alerts, making alert management significantly more efficient. Lastly, Azure Monitor integrates with Azure Service Health, helping you monitor the health of Azure services that your applications rely on. With this feature, you can get real-time updates on service outages or planned maintenance that may affect your resources, and set up alerts for service health incidents to ensure you're notified as soon as an Azure service impacting your resources is experiencing an issue. Now, let's wrap things up by exploring a few best practices to effectively leverage these Azure Monitor features. Firstly, use Log Analytics workspaces to centralize your data. This allows you to query and analyze logs across multiple subscriptions and environments. Secondly, combine alerts with Logic apps or Azure Automation to create self-healing systems that can automatically respond to issues, such as scaling resources or restarting services. And finally, visualize the most critical metrics and logs using custom dashboards. These dashboards help stakeholders and technical teams monitor system health in real time without diving into individual queries. In this video, you discovered the diverse and powerful set of features Azure Monitor offers to handle holistic monitoring of your applications, infrastructure, and the health of Azure services. By combining these capabilities, you can gain comprehensive visibility into your environment, automate responses to performance issues, and ensure your Azure infrastructure is optimized for peak performance. Picture this: you're driving a high-performance car, one that gives you instant feedback on everything happening under the hood. That's how Azure Monitor operates within your cloud environment. It doesn't just track performance, it gives you real-time insights into every moving part, so you're always in control. In this video, you're going to take a deep dive into the core components of Azure Monitor, from the engine that drives it, Log Analytics, to the performance gauge, Application Insights, and beyond. Let's explore how each piece works together to create a seamless, unified monitoring experience. At the heart of the Azure Monitor engine is Log Analytics, your go-to tool for collecting and querying logs with precision. With Log Analytics, you can centralize telemetry data from all your resources into one unified workspace. That means all metrics, logs, and activity data from different services funnel into one place, the Logs Analytics workspace, making it much easier to analyze data from various services. When you need to dig deeper into your data, Kusto Query Language, or KQL, steps in as your advanced tool for querying logs. With KQL, you can filter, sort, and even join data from multiple sources, giving you deep insights into system performance, security, and overall operational health. Shifting focus, Application Insights serves as the performance gauge for your system, monitoring how your application performs and how users interact with it. This tool is designed to capture telemetry from your app and gives you a deep understanding of how it's functioning, especially when it's under different loads or scenarios. One standout feature is dependency tracking, which enables you to monitor how different parts of your app interact, whether it's database calls, application programming interface or API requests, or external service dependencies. This helps you quickly pinpoint where performance bottlenecks occur, whether it's within the app code or an external service. And it doesn't stop there. With custom telemetry, you can go beyond the standard metrics by configuring Application Insights to track specific events, such as user actions, exceptions, or even key business metrics that are crucial to your app's success. Now, let's focus on metrics, the real-time pulse of your system's health and performance. In Azure Monitor, metrics provide live, high-frequency data that gives you an instant overview of how your resources are functioning. Metrics excel in granularity and speed, updating in near real time, which makes them ideal for monitoring things like CPU usage, memory consumption, and network bandwidth. This immediate insight is critical for reacting quickly to spikes in demand or system issues. In addition to the core infrastructure metrics, you have the flexibility to create custom metrics tailored to your business needs. This allows you to track specific performance indicators that matter most, ensuring you have full visibility into your system's operations. Another essential component of your Azure Monitor engine is alerts. But instead of just providing basic notifications, imagine your monitoring system not only detecting potential issues, but also automatically fine-tuning itself to keep everything running smoothly. This is where dynamic thresholds and automated actions come into play. Rather than relying on fixed limits, like triggering an alert when CPU usage exceeds 80%. Azure Monitor learns from historical data to set adaptive thresholds. These thresholds adjust automatically to typical performance patterns, reducing false positives and ensuring more accurate alerts. What's more, with alert actions, you can automate responses to alerts, from sending email to initiating automated fixes through Azure Logic Apps or Azure Automation. This ensures that your system can respond quickly and efficiently to potential issues, helping you maintain seamless operations. Moving on to a specialized component of Azure Monitor, Network Insights is designed for organizations that rely heavily on network infrastructure. It offers in-depth visibility into network health, allowing you to monitor the flow of traffic across your Azure resources. One standout feature of Network Insights is network topology mapping, which visually represents how your resources are connected. This helps you quickly identify potential bottlenecks or issues affecting performance. In addition to topology mapping, Network Insights provides customizable views into resource health. You can filter resources by subscription, resource group, and type, or sort them by name or resource count to suit your needs. To streamline your view further, the search box allows you to quickly find specific resources and their dependencies. For example, searching for AGW PIP, a public IP, returns both the public IP and its associated application gateway. You can also view the overall health and metrics of all resources across selected subscriptions and resource groups. Once you've filtered or searched for resources, they are displayed in a tile format. Each tile represents a resource type, showing the number of instances deployed and their health status, helping you quickly assess the overall state of your network infrastructure. Let's bring everything together. Each component of the Azure Monitor forms a critical part of the overall monitoring solution. When combined, these tools provide a unified view of your entire environment, allowing you to effortlessly monitor both your infrastructure and application performance. For instance, you can use Log Analytics to track infrastructure metrics, while Application Insights keeps an eye on your application-level data. Metrics deliver real-time information, and alerts ensure you're notified the moment a critical issue arises. Add Network Insights to monitor traffic flow, and you complete the holistic view of your environment. Together, these components create a powerful, integrated monitoring system that helps you stay on top of performance across every layer of your Azure ecosystem. Finally, let's highlight a few best practices for getting the most out of Azure Monitor's powerful components. First, correlate data from both Application Insights and Log Analytics to get a complete view of your application and infrastructure health. This gives you a clearer picture and helps you identify issues faster. Second, take advantage of automated remediation. By integrating Logic Apps or Azure Automation, you can reduce downtime by automating responses to critical alerts. Finally, define custom metrics and events tailored to your business needs, giving you more granular control over what's being monitored and ensuring you track the performance indicators that matter most. In this video, you explored the core components of Azure Monitor and how they work together. By leveraging these tools, you can tailor your monitoring strategy to meet the specific needs of your environment. These components form the backbone of a powerful monitoring system, providing insights at every layer from infrastructure to applications, ensuring you maintain complete control over your Azure resources. Imagine you're responsible for managing your organization's cloud infrastructure and everything is running smoothly until an unexpected issue threatens to disrupt critical services. What if you had the power to detect problems before they cause disruptions? That's where Azure Monitor steps in. With real-time insights into your system's performance, Azure Monitor helps you proactively monitor and address issues before they escalate. In this video, you'll walk through configuring Azure Monitor step by step. You'll learn how to configure and enable Azure Monitor to monitor your virtual machines, or VMs, ensuring that you can track their health and performance. Let's begin by creating a Log Analytics workspace, which will collect logs and metrics from your virtual machines. To get started, sign in at portal.azure.com. Once you've done so, you'll be navigated to the Azure Portal homepage. Now, in the top search bar, type Log Analytics and select Log Analytics Workspaces from the results. Next, on the Log Analytics Workspaces page, select Create. This opens the Create Log Analytics Workspace page where you'll configure your new workspace. The subscription is where you can choose the Azure subscription you want to use. You can also choose an existing resource group or create a new one by clicking Create New. You then enter a descriptive name for the workspace, such as VM Monitoring Workspace. For the region, select the closest region to your resources, for example, East US. After providing the necessary details, select Review and Create, and then Create to finalize the workspace. It may take a few minutes for the workspace to be created. Once the deployment is complete, you will receive a confirmation, and then the workspace will be available for further configuration in Azure Monitor. With the Log Analytics workspace ready, the next step is to enable Azure Monitor for VMs so that data collection can begin. In the Azure portal search bar, type Azure Monitor for VMs and select it from the search results. You'll be directed to the Azure Monitor Marketplace page. Next, select the resource group where your VM resides. Then, select the Log Analytics workspace you created previously from the drop-down menu. In this instance, VM Monitoring Workspace. Next, select Review and Create, and once the validation is complete, select Create to deploy Azure Monitor for VMs. Once the deployment has finished, the VM Insights workspace will be displayed. After setting up Azure Monitor, the next step is to ensure that your VMs are actively being monitored. By connecting your VMs to Azure Monitor, you can begin collecting performance metrics and logs, allowing you to track the health of your VMs and identify any potential issues before they impact your operations. In the Azure Monitor dashboard, navigate to Workspace Data Sources in the left-hand menu and select Virtual Machines. This will display a list of all the available VMs. Next, select the VM you would like to monitor, for example, Production VM1. If no VMs are available in your tenant, consider creating a demo VM for this purpose. Then, select Connect to start monitoring the VM. This process will automatically install the Microsoft Monitoring Agent, or MMA, on the VM. The MMA is essential for collecting performance data and analyzing dependencies between services. Once the VM is connected to Azure Monitor, the status of the VM displays as this workspace. Now that Azure Monitor is configured and your VMs are connected, the final step is to validate that MMA is correctly installed. This ensures that data is being continuously collected and that the monitoring agents are functioning as expected. In the Azure Monitor dashboard, navigate to Workspace Data Sources in the left-hand menu and select Virtual Machines. Next, select your VM from the list. In this example, Production VM1. Now, on the left-hand menu, expand Settings and select Extensions and Applications. Finally, verify that the Microsoft Monitoring Agent status is listed as Provisioning Succeeded. Congratulations! You've successfully enabled Azure Monitor for your virtual machines and verified that performance data is being captured in real time. With these tools in place, you're ready to proactively monitor your VMs and ensure smooth operations. Azure Monitor's intuitive features make it easy to track performance and ensure uninterrupted operations. Now you have everything you need to maintain a healthy and resilient cloud environment. By staying proactive, optimizing your VMs, and keeping your Azure infrastructure running efficiently, you're in control of a smarter, more reliable system. Consider this scenario. A startup has launched an online grocery web application, which gets off to a fast start and draws a large user base immediately. However, soon there is a surge of customer complaints about sluggish load times and show-stopping errors. Eventually, the IT team is able to locate and correct the causes behind these issues, but at a significant cost of time. What if the IT team could identify these causes right away and even track them before they become problems to begin with? This is where Azure Monitor metrics come into play, serving a vital role in Azure Monitor's real-time monitoring capabilities. Metrics allow you to track the performance and health of your resources by measuring specific characteristics such as CPU usage, memory consumption, or network activity. In this video, you'll unpack what Azure Monitor metrics are, their key types, and how they are used to monitor the state of your infrastructure. While you won't need access to Azure credits for this conceptual understanding, the insights gained here will help you effectively plan and apply metrics in real-world scenarios. Metrics in Azure Monitor are quantitative data points that represent the state of your resources. They are collected at regular intervals and stored in time series format, providing a real-time view of how your Azure resources are performing. Now, let's break down how metrics are structured and learn why they matter. First, Azure Monitor collects two primary types of metrics. One is platform metrics, which are generated automatically by Azure services. Examples include CPU usage, disk I/O, and network bandwidth. These metrics give you a direct view into the performance and resource utilization of your virtual machines, databases, and other services. You also have custom metrics, which can be created to track business-specific or application-specific data points. For example, you could track the number of completed transactions per second for an e-commerce site or API response times for a web application. Using a combination of platform metrics and custom metrics allows you to monitor both system-level performance and application-specific performance indicators. Because Azure Monitor metrics are designed for real-time monitoring, data points are usually collected once every minute for most Azure services. This frequent data collection allows you to identify and respond to performance issues quickly. High-frequency metrics provide near real-time data, allowing you to make rapid decisions. For instance, if your CPU usage spikes, you can immediately scale resources or troubleshoot the cause. Historical metrics, on the other hand, help you analyze trends over time, allowing for capacity planning and performance tuning. The combination of real-time and historical metrics enables both immediate troubleshooting and long-term optimization of resources. You should know that metrics are also central to defining the health of your resources. Azure Monitor allows you to set thresholds that determine when a resource is considered healthy or degraded. For example, you could define a healthy virtual machine as one where CPU usage stays below 80%. Once this threshold is breached, you could trigger an alert or begin an investigation. For performance metrics, defining CPU, memory, and disk I/O is crucial for ensuring your infrastructure performs efficiently. While on the health metric side, error rates or network latency help identify potential failures before they occur. This shows that metrics aren't just passive data. They help you define performance baselines and detect anomalies in real time. Previously, you learned how alerts can be triggered based on metrics. By configuring metric-based alerts, you can automatically trigger responses when key thresholds are breached. For example, you could set an alert that notifies you if CPU usage exceeds 85% for more than 5 minutes. This would give you time to take action before performance degrades. But you're not limited to just static thresholds for alerts. Another option is dynamic thresholds. Azure Monitor can also apply machine learning to set dynamic thresholds that adjust based on the normal behavior of the resource. This helps reduce false positives and ensures alerts are only triggered when necessary. Metric-based alerts ensure you're notified in real time about performance issues, allowing for immediate action to prevent downtime or resource overload. Finally, let's wrap up with some best practices for optimizing the collection and use of Azure Monitor metrics. One is to avoid over-monitoring, as tracking too many metrics can lead to data overload. Focus on the metrics that are most critical to your application or system. You should also customize your metrics in addition to platform metrics. Consider defining custom metrics that reflect your specific business needs, like tracking the success rate of transactions or monitoring API usage. It's also important to correlate with logs. Metrics provide high-level insights, but combining them with log data offers a deeper understanding of what is happening in your environment. In this video, you unpacked Azure Monitor metrics to better understand how they provide a real-time view into the performance and health of your Azure resources. By recognizing the types of metrics available, how to set thresholds, and how to configure alerts, you can build an effective monitoring strategy that helps you optimize performance and respond to issues before they affect users. By now, you probably know quite a bit about the capabilities and benefits of using Azure Monitor to track your resource health and performance, and you're probably ready to put that knowledge into action. By the end of this video, you'll know how to do just that. Expect a walkthrough of the process for configuring basic monitoring using the Azure portal. You'll do this using several Azure tools, starting with Virtual Machine Insights, otherwise known as VM Insights. This powerful Azure service provides in-depth visibility into the performance, health, and dependencies of your virtual machines and VM scale sets. By enabling VM Insights, you can monitor key metrics like CPU utilization, memory usage, disk I/O, and network performance, making it easier to identify performance bottlenecks, troubleshoot issues, and optimize resource usage. You'll also explore how the Azure Monitor Agent, or AMA, which replaces legacy agents, simplifies and improves data collection, and you'll find out how to leverage data collection rules, or DCRs, for precise control over telemetry data. This video will guide you to set up and configure monitoring to get the most out of Azure's capabilities. Let's start by getting familiar with VM Insights. This solution provides detailed monitoring and analysis of your VMs and scale sets. Key features include performance monitoring, which tracks metrics like CPU, memory, disk, and network performance in real time. Health monitoring, to provide visibility into the health of your infrastructure and alert you to issues before they impact operations. Dependency tracking, which maps the dependencies and connections between VMs and other Azure resources. And analytics and alerts, which integrates with Log Analytics and Azure Monitor to provide insights and customizable alerts for proactive problem resolution. Next, you have the Azure Monitor Agent, representing the new standard of collecting telemetry data in Azure. It provides several advantages over older agents, like the Log Analytics agent. One is unified data collection. AMA collects both logs and metrics with a single agent, simplifying deployment and management. Another is cross-platform support, meaning that it works seamlessly on both Windows and Linux VMs. AMA also offers enhanced performance and security compared to legacy agents, making it a more efficient solution. Centralized management is another perk of AMA, which allows centralized configuration for all your monitoring needs across Azure and hybrid environments. And finally, AMA optimizes resource usage, making data collection more efficient and cost-effective. One more important tool to know about is data collection rules. These are configurations used with the AMA to define exactly what data needs to be collected and where it should be sent, such as a Log Analytics workspace. DCRs provide deep customization options, allowing you to tailor data collection based on operational and compliance requirements. Key features include granular control over what data is collected, ensuring that only relevant logs and metrics are gathered. Flexible management as DCRs can be applied across different resources to enable consistent monitoring configurations. Customizable data collection that enables you to capture specific metrics or logs based on your needs, ensuring operational efficiency. And scalability through support for monitoring at scale by optimizing data collection across large environments. So now that you are aware of the tools at your disposal, let's go through the steps for a basic monitoring configuration. To start monitoring a VM in Azure, the first step is to enable Azure Monitor Insights, which provides detailed monitoring capabilities, including performance data and dependency tracking. To do so, first navigate to the Azure portal at portal.azure.com and log in with your credentials. Then, in the search bar, type Virtual Machines, and from the list of VMs, select the one you wish to monitor. In the VM Overview page, scroll down to the Monitoring section and select Insights. If Insights isn't already enabled, you will see a prompt to enable it. Select Enable to activate monitoring for the selected VM. Once you enable Insights, you will be prompted to configure the monitoring setup. You can do that by following these steps. Select your Azure subscription and, if needed, create a new DCR. The DCR defines the type of data, in this case logs and metrics, that will be collected and where it will be sent, such as the Log Analytics workspace. After creating or selecting a DCR, the monitoring setup will begin to collect performance data, including CPU, memory, disk, and network metrics. After a short period, VM Insights will begin displaying performance metrics for your VM. To review the data, navigate to the Metrics section in the Insights view of your VM. Here, you can review both real-time and historical data. The data will include key performance indicators such as CPU utilization, memory usage, disk I/O, and network performance. The Metrics section presents data in easy-to-read charts and reports. You can filter and customize these views to focus on specific time periods or metrics that matter most to your environment. In this video, you are guided through the steps for setting up a basic monitoring configuration by enabling Virtual Machine Insights, configuring monitoring with the Azure Monitor agent, and tailoring data collection using data collection rules. This means you now have a robust and scalable solution for monitoring your virtual machines in Azure. The insights provided will help you identify performance bottlenecks, optimize resource usage, and proactively manage the health of your infrastructure. This process ensures that you have real-time visibility into the performance and dependencies of your VMs, allowing you to troubleshoot issues effectively and maintain optimal performance. As you know, Azure Monitor is a powerful solution that can greatly enhance your monitoring ability. But as with any tool, you should understand how to utilize its strengths to get the most out of it. That's why in this video, you'll focus on best practices for configuring Azure Monitor effectively to optimize performance, ensure accurate monitoring, and minimize unnecessary costs. Moving past basic configurations, you'll learn to enhance your Azure Monitor setup by leveraging advanced features and configurations to ensure long-term operational success. Let's start with optimizing data collection rules, or DCRs. These play a critical role in ensuring efficient data collection in Azure Monitor. One best practice is to configure DCRs to capture only the most important telemetry for your monitoring goals, as opposed to all available logs and metrics. This not only reduces storage costs, but also ensures that the most relevant data is being analyzed. If you are working in a hybrid environment, you'll also want to configure custom DCRs that apply specific rules to different VM types, workloads, or environments. And make sure that your DCRs are optimized to avoid collecting redundant telemetry that isn't directly actionable, as over-collecting data can lead to unnecessary storage costs. Another useful strategy is to enhance alerts with custom thresholds. While static, one-size-fits-all thresholds are fine early on, it's essential to customize them to avoid alert fatigue and ensure meaningful alerts. For critical metrics like CPU utilization, memory usage, and network latency, leverage dynamic thresholds that adjust automatically based on historical trends and machine learning models. This minimizes false alerts caused by temporary spikes and only triggers alerts when deviation is statistically significant. You can also create granular alerting scopes by specifying multiple conditions in a single alert rule. For instance, combine multiple metrics into one rule to trigger alerts only when several related issues occur simultaneously. And then there are action groups to automate responses when an alert is triggered. This could include sending notifications to key stakeholders, running an Azure Automation runbook to remediate the issues automatically, or integrating with third-party services for further actions. Let's move on to another area of consideration, which is scaling Azure Monitor for large environments. When monitoring large-scale environments, such as applications with many VMs or distributed microservices, the configuration must scale without compromising on performance. One way to achieve this is with a carefully planned Log Analytics workspace architecture. Multiple workspaces can be used to segment data for different teams or environments, which distributes monitoring workloads and keeps the data manageable. If you're using VM scale sets, you can configure VM Insights to automatically detect new VMs added to the scale set and ensure that monitoring is automatically enabled. This reduces the need for manual configuration as the environment scales dynamically. And Azure Monitor's centralized dashboard offers a way to aggregate data across multiple workspaces. This ensures that you can easily correlate events and performance metrics from different sources without having to manually merge logs. Remember that Azure Monitor doesn't exist in isolation, and integrating it with other services is essential for a robust monitoring solution. Log Analytics is one service that combines well with Azure Monitor, allowing you to perform advanced queries, create custom dashboards, and execute in-depth analyses of your logs and telemetry. This is especially helpful for root cause analysis and tracking historical trends across services. There is also Azure Automation, which integrates with Azure Monitor to run remediation scripts automatically when certain alert conditions are met. This is particularly useful for auto-scaling workloads or restarting services when an alert is triggered. One often overlooked aspect of Azure Monitor is the management of retention policies for collected logs and metrics. Storing data for longer periods is useful for historical analysis, but can lead to increased costs. One way to prevent this is by setting custom retention periods for logs and metrics in each workspace. For example, keep mission-critical data like security logs for longer periods, but performance logs for shorter durations. And for data that is no longer needed in real time but still needs to be accessible, you can archive it to cheaper storage to reduce costs while still retaining the ability to query older data when necessary. Finally, monitoring configurations are not set and forget tasks. It is essential to continuously review and update your Azure Monitor setup to adapt to changing workloads, environments, and business needs. An important practice is to regularly review the performance data and alerts generated by Azure Monitor. Ask yourself, are the alerts actionable? Is there too much noise? Use this feedback to guide you in refining thresholds, metrics, and DCRs. As your infrastructure grows, it's also important to ensure that alert fatigue doesn't set in. Regularly review which alerts are being triggered and whether they remain relevant. And as more workloads move to the cloud, automation becomes critical. Take advantage of Azure Monitor's automation capabilities to respond to alerts automatically, reducing the need for human intervention and allowing for quicker issue resolution. In this video, you picked up several best practices for maximizing the effectiveness of your Azure Monitor configurations. By implementing them, you can improve performance monitoring, manage costs, and ensure scalability. Furthermore, advanced configurations like custom thresholds, DCRs, and workspace architecture help ensure that your monitoring solution remains efficient, cost-effective, and highly responsive to changes in your Azure environment. With careful planning and regular reviews, you can ensure that Azure Monitor continues to meet your operational needs, giving you deep insights into both the performance and security of your virtual machines and workloads. Modern cloud technology has enabled companies to move their infrastructure online, an approach with benefits ranging from enhanced cost efficiency to superior scalability. However, it also brings increased complexity that requires a watchful eye to ensure consistent, trouble-free performance. Fortunately, you've become familiar with a powerful tool that will help you to do just that. That tool is Azure Monitor, a comprehensive monitoring service that empowers users to gain a full understanding of their Azure resources. In this module, you built a foundational understanding of Azure Monitor, including its core components, key features, and how to set up basic configurations. Before moving on, let's recap the most important concepts that you learned about. You started off with an introduction to Azure Monitor that covered its components and how it collects data. You found that this service consists of metrics like CPU usage, which shows the performance of resources over time, logs, which give detailed data into operations happening on your resources, alerts or notifications that inform you of specified conditions being met, such as memory utilization, passing a defined threshold, and application insights, a service that provides deep insights at the application level. You also learned that Azure Monitor integrates with most Azure services and works across cloud and on-premises resources alike to collect telemetry data, giving you a complete picture from end to end. After this overview, you examined several scenarios that demonstrate how Azure Monitor can be applied and how it enables proactive monitoring to catch issues before they cause disruptions. You then completed an activity that guided you to design a monitoring plan for an application using Azure Monitor. This called for identifying appropriate metrics, configuring monitoring settings, and setting up alerts. With the basics covered, you progressed by taking a deeper dive into Azure Monitor's features and components. To achieve a unified monitoring solution, you discovered that Azure Monitor has cross-resource correlation capabilities that can analyze metrics and logs across services, along with monitoring across environments for Azure and non-Azure resources alike. Azure Monitor can also extend its base functionalities and produce deeper insights with advanced features such as Application Insights, which captures detailed application-specific metrics, and Log Analytics for advanced querying using Kusto Query Language, or KQL. Another important aspect of the Azure Monitor that you learned about is customization. While this service features built-in metrics for common performance indicators, such as CPU usage and network bandwidth, it also allows for the creation of custom metrics that a business can use to better meet their unique monitoring needs. This tailored approach also applies to alerts, for which you can define static or dynamic thresholds and specify the actions that an alert triggers. After picking up some configuration tips and best practices for implementing these advanced features, you took on an exercise that had you configure Azure Monitor's components for a virtual machine. This included creating a Log Analytics workspace for storing collected data and validating your setup. The last part of this module gave you more practical experience as you focused on configuring Azure Monitor in the Azure portal. This entailed becoming familiar with several Azure tools. This includes Virtual Machine Insights, otherwise known as VM Insights, a service for monitoring the performance of virtual machines and VM scale sets. There is also Azure Monitor Agent, or AMA, which centralizes metric and log data collection into a single agent to simplify deployment and management. And Data Collection Rules, or DCRs, which direct the AMA on what data to collect and where to store it. After going over some key considerations, tips, and best practices that concern configuring your Azure Monitor, you put everything together for an activity that guided you to configure monitoring for an example virtual machine that hosts an application. This had you enable VM Insights and define DCRs to specify and collect data for the most pertinent metrics. By completing this module, you now possess a foundational understanding of what Azure Monitor is capable of and how to set up basic configurations. That means you're now ready to explore more advanced techniques for keeping watch on your Azure environments.
Cell phones have impressive capabilities, such as storing vast amounts of photos, apps, and messages in various folders. Azure Storage functions similarly but on a much larger cloud-based scale, efficiently organizing and storing massive amounts of data, including files, videos, and communications. It also replicates data across multiple cloud locations, ensuring it's both safe and accessible from anywhere. Just like you secure your phone with a passcode, Azure uses encryption and access controls to protect your data, keeping it secure and private. Azure Storage is a key service in Microsoft's cloud platform, offering scalable, durable, and secure storage solutions for diverse data needs. In this video, you'll learn the fundamentals of Azure Storage and see why it's indispensable for architects, developers, and IT professionals seeking to leverage cloud-based storage fully. Before focusing on the details, let's review its core concepts. At the heart of Azure Storage is the idea of a storage account. These storage accounts act as the gateway to all Azure storage services and include blob storage, file storage, queue storage, and table storage. Each of these services is tailored to specific use cases and offers flexibility in how data is stored, managed, and accessed to meet various needs. Let's explore each, starting with binary large object, or blob storage, which is designed to handle unstructured data such as images, videos, and log files. It's particularly suited for storing large amounts of unstructured text or binary data. Blobs are stored in containers within a storage account, allowing for organized and secure data storage. Next up is Azure File Storage, which provides fully managed file shares in the cloud that are accessible via the Server Message Block or SMB protocol. This makes it ideal for lifting and shifting existing applications to the cloud without changes, especially those that rely on traditional file shares. There's also queue storage, which is used to store large numbers of messages that need to be processed asynchronously. It's beneficial in scenarios where application components need to communicate with each other and pass messages back and forth. Last up is stable storage, which is a NoSQL database, meaning it doesn't require a fixed schema like traditional relational databases like SQL Server and MySQL. Instead, it uses a key-value store model, which is a simple yet powerful way to store data. It's designed for applications that require high scalability with a need for flexible data schemas. Overall, Azure Storage is built to be scalable, accommodating both small-scale and enterprise-level applications. It can automatically allocate resources as your data grows, ensuring that you do not have to worry about capacity constraints. This scalability is coupled with durability guarantees, ensuring that your data is replicated across multiple locations within the same region or across different regions. The replication strategy provides high availability and resiliency, even in the event of a hardware failure. Now let's examine some of its security benefits. Security is a primary concern for any storage solution, and Azure Storage is equipped with a robust set of security features to protect your data. These features include encryption at rest and in transit, role-based access control or RBAC, and integration with Azure Active Directory or AAD. Encryption at rest ensures that all data is encrypted using Microsoft managed keys or customer managed keys. RBAC allows you to fine-tune who has access to your data, while AAD integration simplifies the management of identities and permissions. Another great feature of Azure Storage is how it's deeply integrated into Azure's networking infrastructure. For instance, you can restrict access to your storage account to specific virtual networks or even specific public IP addresses, enhancing security. This integration with Azure networking services like Azure Virtual Network and Azure Private Link ensures that your data remains secure and accessible only to the intended users. Consider a scenario where a multinational company is migrating its on-premises data center to Azure. This company has vast amounts of unstructured data in the form of media files, customer documents, and transaction logs. By leveraging Azure Blob Storage, the company can store this data in a scalable and cost-effective manner, ensuring that it can easily handle future growth. Additionally, with Azure File Storage, it can migrate existing applications to the cloud with minimal changes, utilizing the same file sharing protocols its applications already rely on. As the company expands its operations across different regions, Azure's global presence allows it to replicate its data across multiple regions, ensuring high availability and disaster recovery capabilities. Security is also paramount for the company, given the sensitive nature of the customer data they handle. Azure Storage's encryption and RBAC features enable them to protect this data, meeting both internal and external compliance requirements. Its role within Azure's broader networking ecosystem is also crucial. By integrating storage solutions with services like Azure Content Delivery Network or Azure CDN, organizations can deliver content to end users with minimal latency. This is especially beneficial for global enterprises with a dispersed customer base. The combination of Azure Storage and Azure CDN allows for the caching of frequently accessed data closer to the users, improving performance and reducing load times. This integration could benefit the multinational company's delivery of media content, such as promotional videos and product demos, to customers around the world. By caching this content at edge locations through Azure CDN, the company ensures that its customers have a seamless experience regardless of their location. Azure Storage is a fundamental component of Microsoft's cloud ecosystem, providing versatile, scalable, and secure storage solutions. Whether you're dealing with large-scale unstructured data, moving existing file-based applications to the cloud, or managing asynchronous messaging between application components, Azure Storage has a service designed to meet your needs. Its deep integration with Azure's networking infrastructure further enhances its capabilities, ensuring that your data is not only secure but also highly accessible. By understanding and leveraging Azure Storage's core concepts, organizations can build robust, scalable, and secure solutions that meet the demands of today's digital landscape. Whether you're a developer, IT professional, or architect, mastering these fundamentals is key to unlocking the full potential of Azure's cloud platform. Azure Storage data services form the backbone of cloud-based data management. Much like a business manages its warehouse space, Azure Storage allows companies to store and access data as needed, offering scalable, secure, and highly available solutions tailored to meet specific requirements. Imagine a retail business with products stored in various warehouses. Azure Storage works similarly, efficiently organizing and scaling data based on demand while ensuring it's always available and protected, no matter where the customer is located. This video will guide you through Azure Storage's core concepts, key components, and different types of storage accounts. Understanding these foundational principles is essential for organizations looking to optimize their data storage and management strategies using cloud technology. Whether your data is structured or unstructured, Azure has a solution to help meet your business needs. Let's begin with an overview of Azure Storage's key components that provide the foundation for its reliability, scalability, and security. These components include storage accounts, containers, and data objects. First up are storage accounts, which are containers that group a set of Azure storage services. They act as a management layer, allowing users to manage access, billing, and configuration settings. Each storage account has a unique namespace that serves as the access point for stored data, ensuring that data is isolated and secure. Next are containers, which act as logical groupings of data objects. For example, in Azure Blob Storage, containers organize binary large objects or blobs and can hold any number of blobs. This organization allows for better data management and accessibility. Last are data objects, which are the actual files or data stored within Azure Storage. Depending on the type of storage used, these objects can be blobs, files, queues, or tables. Each type of data object serves a different purpose and is optimized for specific use cases. Earlier, you were introduced to the various types of Azure storage services, which included blob storage, file storage, queue storage, and table storage. Now let's discuss how each of these services is tailored to support specific use cases. Blob storage, the most common of these, is designed to store unstructured data like images, videos, and backups. It's ideal for scenarios where large amounts of data need to be stored in a scalable manner. For instance, a media company might use it to store and stream video content to millions of users worldwide. While file storage provides fully managed file shares accessible via the SMB protocol. It's ideal for applications that need shared access to files across multiple virtual machines. For example, companies could use file storage to store and share documents, code repositories, and logs among their development teams. Queue storage stores large numbers of messages that distributed applications can access. It provides reliable messaging between application components, making it useful for decoupling application layers. An example of this is where online retailers use queue storage to manage order processing, where each order is processed asynchronously by different parts of the system. Lastly, table storage is a NoSQL key-value store designed to store large amounts of structured data. It's ideal for scenarios requiring high availability and quick access to large data sets. For example, logistics companies could use table storage to store and quickly retrieve shipment tracking data. An essential element of Azure Storage is effective data management, which is key to ensuring that stored data remains secure and accessible. Azure offers various features to manage data efficiently. Let's explore these features now. First is access management. Azure Storage uses role-based access control, or RBAC, and shared access signatures, or SAS, to manage who can access data and what operations they can perform. For instance, streaming platforms could use RBAC to grant specific access rights to their content creators and viewers, ensuring that only authorized users can upload or download media files. Next is data redundancy. Azure offers multiple redundancy options to ensure data durability and availability. These options include locally redundant storage, or LRS, geo-redundant storage, or GRS, and read-access geo-redundant storage, or RAGRS. For example, a company might choose GRS to ensure that its critical development files are replicated across multiple geographic locations, providing disaster recovery capabilities. You also have data lifecycle management, which allows organizations to automate the transition of data between different access tiers. This is useful for managing costs by moving less frequently accessed data to lower-cost storage tiers. For instance, a company could implement a lifecycle policy that moves completed shipment records to an archive tier after a certain period. Another key feature of Azure Storage is how it provides encryption for data at rest and in transit, ensuring that data is protected from unauthorized access. By default, all data stored in Azure is encrypted using Microsoft managed keys, but customers can choose to use their own encryption keys. Last is scalability and performance. Azure Storage is designed to scale out to meet businesses' growing demands. It supports massive amounts of data and can handle millions of requests per second. For example, a company might experience spikes in traffic during holiday sales, but Azure Storage's scalability will ensure that its data storage needs are met without any performance degradation. Azure Storage Data Services offer a powerful and adaptable solution for storing and managing data in the cloud. By understanding its components, features, and key concepts, businesses can harness Azure Storage to address their unique needs. Whether it's storing unstructured data, sharing files across teams, managing messaging between application components, or handling structured data sets, Azure Storage provides the necessary tools and capabilities to ensure data remains secure, readily accessible, and scalable. With its broad range of services, Azure Storage is equipped to support diverse data management requirements across various industries. Imagine working for a company that aims to expand its operations globally. With such growth, the volume of data generated daily can surge significantly, presenting new challenges in managing and storing this data. This increased demand calls for a scalable, secure, and cost-efficient storage solution that can seamlessly adapt to the company's evolving needs. Enter Azure Blob Storage, a powerful and flexible option designed to handle the ever-growing data storage requirements of modern organizations. Azure Blob Storage not only provides a scalable solution, but also ensures data security, accessibility, and affordability at every stage of your company's expansion. In this video, you'll explore some practical settings you can apply to configure Azure Blob Storage for your organization, which will empower your business to leverage this cloud storage service efficiently. You previously created a storage account and resource, so now let's explore some advanced configurations, including data protection, security features, and networking. For instance, by enabling soft delete, you can protect against accidental blob deletion. You should note that after making any required adjustments, you can review the configuration in the Review and Create tab and select Create to deploy your updated storage account. Once your storage account is set up, you can configure Azure Blob Storage to store, manage, and access large volumes of unstructured data. Let's do this now. Start by navigating to a storage account you created in the Azure portal and selecting Containers under the Blob Service section. Now click on Plus Container to create a new container, which serves as a logical grouping for blobs. Give the container a name, ensuring that you keep it in lowercase and include letters, numbers, and hyphens. And be sure to configure the access level according to your security requirements. The private option is the most appropriate choice for sensitive customer data. Once the container is created, using the Create button at the bottom, you can upload blobs by clicking on the container and clicking plus Upload. You can select files from your local machine to upload. This step can be automated using tools like Azure CLI, PowerShell, or SDKs, making it easier to handle large volumes of data. That's the basic configuration to create blob storage, but there are also some additional considerations. Let's briefly go through them. It's important to configure shared access signatures, or SAS, to delegate access to the blobs. For example, you can generate a SAS token to provide temporary access to external collaborators for a specific project. This adds a layer of security by controlling access at a granular level. You can also set up rules for blob lifecycle management to optimize storage costs. For instance, you can create policies to automatically move infrequently accessed data to cooler storage tiers or delete it after a specified period. Another crucial aspect of configuring your blob storage is ensuring its security, especially when dealing with sensitive information. By default, Azure Blob Storage uses server-side encryption. You can manage your keys or let Azure manage them. For example, you could opt for Customer-Managed Keys or CMK for greater control. Additionally, you can configure your virtual network rules or IP firewall rules to restrict access to the storage account. This ensures that only authorized networks can access the blob storage. Configuring Azure Monitor and Azure Storage Analytics, you can monitor access patterns, log operations, and set up alerts for unusual activities. This enables you to detect and respond swiftly to potential security incidents. Lastly, by integrating Azure Blob Storage into your organization's applications, you can store and serve user-generated content, such as images and videos, from its global user base. Additionally, the development team could leverage the Azure Storage SDK to interact with Blob Storage programmatically, ensuring seamless integration with its existing infrastructure. Azure Blob Storage offers a flexible, scalable, and secure solution for storing unstructured data. By following the configuration steps outlined above, your organization can effectively manage its data storage needs as it expands its operations. With the right configuration, Azure Blob Storage not only meets the current demands, but also scales to support future growth, making it an indispensable asset for any forward-looking organization. Imagine working as part of an IT team tasked with optimizing storage solutions in a fast-paced financial services company where data integrity, performance, and security are paramount. With the ever-increasing demands of modern financial operations, choosing the right storage option is essential to maintaining the company's competitive edge. Azure Managed Disks offer brilliant options that can support a variety of workloads and performance needs. From standard HDDs to premium SSDs, each disk type offers distinct features tailored for specific use cases, including scalability, durability, and cost efficiency. Understanding the different disk types is vital for any IT team, enabling them to make informed decisions that align with their company's unique requirements. This video will guide you through the key features of Azure Managed Disks, offering practical insights to help you make the best choices for your storage infrastructure. Let's begin by walking through the 4 primary Azure Managed Disk types: Ultra Disks, Premium SSDs, Standard SSDs, and Standard HDDs. Each type is designed with specific performance and cost considerations in mind, catering to diverse workload requirements. First is Ultra Disks, the top-tier storage option designed for applications that demand high throughput, low latency, and a high degree of scalability. These disks are ideal for mission-critical databases such as SQL Server or Oracle, where performance is paramount. Ultra Disks provide dynamic scalability, allowing adjustments to input-output operations per second or IOPS, throughput, and capacity without downtime. This flexibility is particularly beneficial for a financial services company during peak transaction periods, ensuring the application remains responsive under heavy loads. Next are premium SSDs, which offer a balance between performance and cost, making them suitable for enterprise-grade applications requiring consistent low latency and high IOPS. For the financial services company, premium SSDs would be ideal for transactional databases, VMs running intensive applications, and scenarios where high availability is crucial. Premium SSDs also support features like Azure Backup and Azure Site Recovery, providing additional layers of protection against data loss. Standard SSDs are next. They are a cost-effective option for workloads that do not require the ultra-low latency of premium SSDs, but still need consistent performance. These disks are well-suited for web servers, application servers, and lightly used enterprise applications. For instance, in a financial services company, standard SSDs could be used for development and testing environments where cost efficiency is a priority. However, the performance is still adequate to simulate production scenarios. Last up are standard HDDs, which are the most economical disk option and are designed for workloads with lower IOPS requirements. These disks are suitable for less critical applications, such as archival storage, backups, and infrequently accessed data. In the context of the financial services company, standard HDDs can be used to store historical transaction data, compliance records, or other large data sets that do not require rapid access. Let's now explore how to ensure optimal performance, reliability, and security when configuring Azure managed disks, which can be achieved by adhering to the following best practices. Firstly, remember to select the appropriate disk type based on workload requirements, which is critical. For instance, Ultra disks should be reserved for workloads where performance is non-negotiable, such as real-time transaction processing. In contrast, standard HDDs might be more appropriate for archival purposes. This alignment ensures that the financial services company avoids over-provisioning expensive resources while maintaining the required performance levels. Next, for applications that require higher IOPS than what a single disk can provide, disk striping across multiple Azure managed disks can be employed. Disk striping involves dividing data into blocks and distributing it across multiple disks in a storage array. This technique is especially relevant for premium SSDs, and Ultra disks can significantly boost performance. However, it's essential to monitor the performance and scale resources accordingly to avoid bottlenecks. For example, in our scenario, the financial services company could stripe multiple premium SSDs to enhance the performance of a transactional database handling thousands of requests per second. It's also important to keep in mind that security is crucial in the financial services industry. Azure managed disks offer robust encryption options to protect data at rest. By default, Azure uses server-side encryption, or SSE, with platform-managed keys, but for added security, you can opt for customer-managed keys, giving your organization greater control over data protection. This additional layer of security ensures that even if the underlying infrastructure is compromised, the data remains protected. The financial services company could leverage customer-managed keys to maintain control over encryption keys, aligning with industry compliance requirements. Next, by implementing Azure Backup and Azure Site Recovery for managed disks, you can ensure business continuity and resilience. These services offer automated backups, point-in-time recovery, and failover capabilities, minimizing downtime during unexpected failures. For example, the financial services company could schedule regular backups of critical VMs using premium SSDs and configure comprehensive disaster recovery plans with Azure Site Recovery. This will ensure that in the event of a data center outage, the application remains operational, protecting both data integrity and business operations from disruptions. Another important practice is to monitor your disk performance continually, which will help identify potential bottlenecks and optimize resource allocation. Azure Monitor and Azure Metrics provide detailed insights into disk performance, enabling proactive management. For the financial services company, setting up alerts for disk latency or IOPS thresholds will help the IT team respond quickly to issues, ensuring that the application remains responsive under varying loads. Lastly, as the financial services company grows, its storage needs will inevitably increase. Azure managed disks allow for seamless scalability, but planning for future growth is essential. The IT team should regularly review disk usage and performance metrics to anticipate when additional resources will be needed. By doing so, the company can avoid performance degradation and ensure that its storage infrastructure evolves in line with its business needs. The financial services industry is highly competitive, and immediate service and action are essential. Any downtime can result in significant financial losses. Understanding and effectively using Azure Managed Disks is crucial for maintaining seamless operations. By selecting the appropriate disk types for specific workloads, implementing robust security measures, and continuously monitoring performance, the IT team can ensure the company's critical applications run smoothly, securely, and efficiently. Azure Managed Disks offer the necessary tools to meet these demands while providing the flexibility to scale as the company grows and its needs evolve, ensuring long-term resilience and success. By now, you've likely grasped that Azure Storage is essential for organizations looking to store data in the cloud, whether they need something small and cost-effective or something robust and scalable. Much like a well-equipped toolbox with the right tools for every task, Azure provides a secure and scalable infrastructure that adapts to the performance and cost needs of various applications. Each type of Azure Storage account is like a dedicated drawer in that toolbox, crafted for specific use cases. Each offers unique benefits in terms of scalability, redundancy, and advanced features, ensuring you have the right solution for every storage challenge. In this video, you'll take your knowledge up a notch by exploring these advanced features, gaining insights into the technical intricacies and performance considerations that can help you optimize your storage accounts, ensuring they scale efficiently and meet your organization's needs. Let's start by discussing advanced features for Azure Blob Storage. Azure Blob Storage is perfect for handling unstructured data like images, videos, and backups, and it's packed with advanced features designed for large-scale use. As you know, one standout feature is the Blob Access tiers, Hot, Cool, and Archive, which help you store data cost-effectively based on how often is accessed. Even better, Azure lets you automate this process with lifecycle management policies. These policies can automatically move data you don't often use from the more expensive Hot tier to the cheaper Archive tier, helping you optimize storage costs without any hassle. Think of it like a media company managing terabytes of video footage using the Blob Hot tier to store current high-demand videos. Over time, this media company could transition older content into the Cool or Archive tiers, while still maintaining retrieval options for long-tail content. Implementing lifecycle management in Blob Storage ensures that companies only pay for high-performance storage when needed. Furthermore, Azure Blob Storage also supports NFS-v3 and SFTP protocols, which offer greater compatibility with existing on-premises systems and Linux environments. The NFS-v3 feature enables Linux clients to mount blob containers from VMs, creating a unified workflow between cloud and on-premises environments. This flexibility is particularly important for large enterprise systems that need to integrate hybrid storage solutions. Another advanced feature of Azure Storage is Data Lake Storage, or ADLS, which is integrated with Blob Storage. ADLS is optimized for big data analytics workloads and allows for hierarchical namespace functionality. This improves performance in scenarios with billions of files. It also provides enterprise-grade security, role-based access controls, and encryption features. Now, let's explore some of the advanced scalability and redundancy features that make Azure stand out. These features allow storage accounts to scale massively, even supporting petabyte-scale data. However, it's crucial to understand the performance limits to prevent bottlenecks. For example, each storage account can handle up to 5,000 requests per second, making it ideal for high-throughput applications like real-time analytics, e-commerce platforms, or Internet of Things solutions. By keeping these performance capabilities in mind, you can ensure your storage accounts are optimized for even the most demanding workloads. Azure Storage offers a variety of redundancy options that ensure data durability and availability. For example, locally redundant storage, or LRS, replicates data within a single data center, or geo-redundant storage and read-access geo-redundant storage replicate data across regions, ensuring failover capabilities in case of regional failures. And Geo-Zone Redundant Storage combines zone redundancy and geo-replication, providing the highest level of protection for mission-critical data. Additionally, for large-scale applications that require high availability, such as a multinational financial services company that processes millions of transactions per second, GCRS can provide a fail-safe mechanism. So, in the case of a zone-level failure, data is replicated to another Azure region without any data loss, ensuring continuity in mission-critical operations. Another advanced feature offered by Azure is premium storage tiers for blobs, files, and disks, which aim to provide low-latency, high-performance storage options. Premium storage is built on SSD technology and designed for high-throughput workloads that require ultra-low latency, such as databases, analytics, platforms, or high-frequency trading systems. Azure Files with premium file shares supports protocols such as SMB and NFS. The premium tier provides up to 100,000 IOPS per share, ensuring minimal latency even with concurrent read-write operations. For instance, a cloud-hosted SQL database that requires near-instant access to configuration files can leverage premium file shares to ensure low latency and high availability. Also, disk storage, used primarily for virtual machines, offers ultra disks for latency-sensitive workloads. These disks support up to 160,000 IOPS per disk, making them suitable for high-performance databases like SQL Server, Oracle, or SAP HANA, which is an in-memory database and application development platform created by SAP. These disks can scale independently of compute resources, allowing enterprises to fine-tune their storage solutions without impacting overall architecture. Lastly, let's turn our attention to the excellent security features Azure Storage accounts provide. With Azure Storage Service Encryption, or SSE, data is encrypted by default. Additionally, customers can opt to manage their encryption keys through Azure Key Vault. This is particularly important for industries with strict regulatory compliance requirements, such as healthcare and finance. Azure also integrates Microsoft Entra ID, formerly Azure AD, for role-based access control. This enhances security by limiting access based on user roles and permissions. Additionally, shared access signatures, or SAS, can be used to provide temporary granular access to storage resources, ideal for scenarios where third-party applications need restricted access. Before finishing, let's explore how a company might use these Azure features together. Imagine a large retail business handling terabytes of data from transactions, inventory, and customer activity. By using Azure Blob Storage alongside ADLS, the company can effortlessly manage both structured and unstructured data. They can also optimize storage costs by leveraging hot, cool, and archive access tiers. This keeps frequently accessed customer data in the hot tier while moving older transaction logs to the archive tier for cost efficiency. Furthermore, with Azure Data Lake Storage, the company can store both real-time and historical data, enabling large-scale analytics on customer behavior without disrupting daily operations. Also, by using GRS, they ensure that even if an entire data center goes offline, their data remains available in a secondary region, keeping operations running smoothly. Lastly, through the implementation of RBAC and encryption, the company can ensure that only authorized personnel have access to specific data. This level of security, along with automatic encryption and audit logging, helps maintain compliance with international data protection regulations like GDPR. In conclusion, Azure Storage offers a highly scalable, secure, and flexible cloud solution with advanced features such as lifecycle management, premium tiers, and robust security integrations. It supports a wide range of applications from real-time data processing to long-term archiving. By selecting the appropriate storage account type and configuring the necessary performance and redundancy settings, companies can optimize both cost and performance to meet their specific business needs. Azure Table Storage is a NoSQL database service that stores structured data in the form of key-value pairs. Think of it like organizing a filing cabinet where instead of needing a specific drawer for each type of document, you have a system where any document can fit anywhere. No predefined rules, just organized by a simple label. That's a bit like what Azure Table Storage does for your data. It gives you the flexibility to store vast amounts of data without the need for a strict schema, making it highly scalable and efficient, perfect for businesses handling large volumes of structured data. This video will explore the configuration process for Azure Table Storage and detail the steps involved. It will also detail how companies can effectively use this service for structured data storage. You previously set up an Azure Storage account. To follow along with this video, you can create a new one following the same process. If you have your storage account ready, then let's go through the rest of the steps. Once the account is created, the next step is to configure the table storage service within this account. Azure Table Storage can be accessed programmatically via the Azure SDK or through the Azure portal. Begin by navigating to the Tables section by clicking on Storage Browser in the left-hand menu. Then in the Tables section, select Add Table. You'll need to choose a unique table name that follows Azure's naming conventions. Keep in mind that table names are case-insensitive and must be globally unique within your storage account. After the table is created, Azure Table Storage will organize your data into tables composed of rows referred to as entities. Each entity is defined by two key elements: a partition key, which groups entities that share the same partition key, optimizing efficient querying and load balancing, and row key, where each entity within a partition is uniquely identified by its row key. This ensures no two entities in the same partition share the same key. Partitioning is an important feature that distributes data across multiple storage nodes to help optimize queries and improve scalability. For example, a retail company tracking customer orders might use the customer ID as the partition key and the order ID as the row key, allowing for quick lookups of orders for each customer. Now that the table is created, you can begin inserting structured data. This can be done programmatically using SDKs, Azure CLI, or even the Azure portal. Azure Table Storage supports multiple client libraries, including those for .NET, Python, and Java. You can insert data into a table by using the Insert Entity function, which can add a new entity to the table. This entity must include the partition key and row key. And Insert or Merge Entity, which adds or updates an entity. If the entity already exists, it updates its properties. If not, it creates a new one. For example, if a logistics company is storing shipment tracking information, it could use Insert Entity to log new shipments with details such as shipment status, location, and expected delivery time. Azure Table Storage also supports flexible query syntax using OData protocols. Queries can be simple or complex, allowing users to retrieve data based on partition key, row key, or custom filters. Querying by partition key is highly optimized, making it an effective way to group related data together. For example, an e-commerce company could query the system to retrieve all customer orders within a specific date range by organizing their queries around the partition key, such as the customer ID. By applying a date filter alongside the partition key, they can efficiently narrow down the results to display only the relevant orders from that customer within the desired time frame. This efficient querying reduces latency and improves performance for real-time applications. So, how does this all come together? Imagine a healthcare analytics company that needs to store real-time patient monitoring data from wearable devices. With Azure Table Storage, they could structure tables using the partition key to represent patient IDs and the row key for time-stamped data entries. Each entity could store important health metrics like heart rate, blood pressure, and temperature. Furthermore, to enhance security, the company could implement role-based access control, or RBAC, to restrict access to authorized medical personnel. They could also generate shared access signatures, or SAS tokens, to grant external researchers temporary access to anonymized data. Additionally, with encryption at rest, patient data is securely stored, ensuring compliance with privacy regulations such as HIPAA. This setup provides a scalable, secure, and efficient solution for managing sensitive healthcare data. As you've discovered, Azure Table Storage is a highly scalable and flexible NoSQL solution for storing structured data. Its schema-less design, combined with advanced security features like RBAC and encryption, makes it suitable for a wide range of applications, from real-time analytics to massive data archiving. By configuring tables with attention to partitioning, security, and redundancy, companies can ensure their data remains accessible, secure, and optimized for performance. A warehouse can store everything from vehicles to equipment, but simply piling everything in and calling it a day isn't efficient. For smoother operations, better security, and cost savings, a more organized system is essential. It ensures everything is secure, easy to manage, and accessible when needed. Azure Blob Storage works in a similar way. It's like a digital warehouse for your unstructured data. Sure, you can simply drop your data in and forget about it, but that's not the most effective approach when dealing with large-scale storage needs. And just like in a physical warehouse, a more organized and optimized system is key to ensuring everything runs smoothly. That's where advanced configurations come in. They allow you to maximize performance, improve security, and cut down on costs, making your digital warehouse not just functional, but highly efficient. In this video, you'll explore Azure Blob Storage's advanced configurations and optimizations, discovering how to unlock its full potential for enhanced performance and efficiency. Let's start by examining how to choose the right access tier. As you know by now, Azure Blob Storage offers 3 distinct tiers: Hot, Cool, and Archive, each designed for specific use cases and cost structures. Choosing the right tier for your data is key to optimizing both performance and cost efficiency. First is Hot tier. This tier is ideal for data that needs to be accessed frequently. It offers the lowest latency and highest availability. However, storage costs are higher in the Hot tier compared to the other options. Next is Cool tier, which is for data that is infrequently accessed but still needs to be readily available. The Cool tier is a more cost-effective choice. The storage costs are lower, but access charges are higher, making it suitable for scenarios where data is read occasionally. Last is Archive tier, which is the most economical option for storing cold data that is rarely accessed and can tolerate higher access latency. However, data retrieval from the Archive tier can take several hours. It is best for compliance or archival purposes where data access frequency is minimal. Consider this scenario. A manufacturing company needs to store machine-generated logs. Real-time logs required for immediate troubleshooting are placed in the Hot tier for instant access. Monthly reports used occasionally for review fit best in the Cool tier. Meanwhile, archived maintenance logs needed by regulators only every few years are stored in the Archive tier, significantly cutting costs. This tiered approach ensures the company balances performance with cost efficiency, using the right storage option for each type of data. Another crucial data management practice organizations adopt is moving data between access tiers as its value and usage frequency change over time. Azure Blob Storage's lifecycle management feature streamlines this process by automating tier transitions and enabling data deletion based on policies you set, optimizing both performance and costs. Lifecycle management strategies work by automatically moving data to the Cool tier after a certain number of days without access. This is useful for data that is initially hot but expected to be accessed less frequently over time. For example, a company's sales reports are stored in the Hot tier initially, but after 30 days of inactivity, they are automatically moved to the Cool tier to save costs. Additionally, data that has been in the cool tier for a prolonged period can also be shifted to the archive tier, reducing long-term storage costs. For instance, after staying in the cool tier for a year, all customer invoices are automatically transferred to the archive tier for long-term, cost-efficient storage. Lastly, for data with a defined retention period, lifecycle policies can be configured to automatically delete blobs after a specified time, ensuring compliance with data governance requirements while minimizing storage bloat. An example is compliance records that are set to be automatically deleted 5 years after creation, ensuring regulatory compliance and reducing unnecessary storage. Another advanced feature for blob storage is indexing, which helps you categorize and search for blobs efficiently. When working with large data sets, performing operations like querying or analyzing metadata can become a bottleneck. Blob indexing allows you to assign custom metadata fields, enabling faster and more efficient queries. For example, a media organization could use blob indexing to manage thousands of video files by categorizing content based on parameters such as release date, genre, or production location. These indices allowed rapid retrieval of the required files for processing, reducing operational lag and speeding up workflows. You also have to keep in mind that data loss can have catastrophic effects, especially when critical files are accidentally deleted. Azure Blob Storage offers the soft delete feature to provide an added layer of protection. When it's enabled, blobs that are deleted remain recoverable for a configured retention period, allowing easy restoration of accidentally deleted data. This can be helpful to organizations such as a healthcare provider who are storing patient records. By enabling soft delete, they can ensure that any accidental or malicious deletion doesn't result in permanent data loss. This additional recovery period provides a safety net during operations that involve significant data modification or cleanup. Next, security is paramount for any organization using cloud storage. Azure Blob Storage offers multiple advanced encryption options to safeguard your data, both at rest and in transit, ensuring solid protection against unauthorized access and breaches. These include server-side encryption, or SSE, which can automatically encrypt all data stored in blob storage using 256-bit AES encryption. You can even bring your own encryption keys for additional control over encryption operations. And client-side encryption, or CSE, which ensures your sensitive data remains encrypted throughout its lifecycle. CSE also allows data to be encrypted before it is sent to Azure and decrypted only after the client retrieves it. This can be particularly important in industries with strict compliance requirements. A standout feature of Azure Blob Storage is its enhanced throughput and latency options. While standard blob storage works well for most use cases, some workloads demand higher performance. Premium blob storage is specifically designed for these scenarios, offering greater throughput, lower latency, and higher availability. This makes it ideal for handling intensive input-output operations in applications like high-frequency trading, real-time data analytics, or high-resolution video processing, where speed and performance are critical. Lastly, for organizations delivering content to a global audience, integrating Azure Blob Storage with a Content Delivery Network, or CDN, can significantly reduce latency and enhance user experience. Azure CDN caches blob data at edge locations close to end users, reducing the load on blob storage and speeding up content delivery. This integration is essential for organizations like e-commerce platforms or news outlets where website performance is crucial for retaining users. By combining Azure Blob Storage with Azure CDN, these organizations can rapidly deliver large media files, documents, or web content across diverse geographic regions. In conclusion, optimizing Azure Blob Storage through advanced configurations such as access tier selection, lifecycle policies, and performance-enhancing features can ensure efficiency and cost savings. By aligning these tools with your organization's unique needs, you can unlock the full potential of your digital warehouse, ensuring smooth operations, secure data management, and high performance. Azure Blob Storage is an ideal solution for unstructured data such as files, backups, media content, and logs. Let's imagine a company called Blue Sky Innovations, which offers cloud-based solutions to customers worldwide. To meet growing demand, they adopt Azure Blob Storage as their primary storage solution, benefiting from its scalability, cost-effectiveness, and security. However, as Blue Sky grows, it faces several challenges, including analyzing customer data, generating reports, and securely managing data backups. To tackle these challenges, Blue Sky can leverage the seamless integration of Azure Blob Storage with other Azure services. This integration not only boosts its storage capabilities, but also provides a comprehensive solution to a variety of real-world business scenarios. In this video, you'll explore how Blue Sky can combine Azure Blob Storage with services like Azure Functions, Data Lake, Synapse Analytics, Cognitive Services, and Azure Backup to create efficient, scalable, and intelligent solutions that address their business challenges. Let's start with Azure Functions, which enables companies like Blue Sky to create event-driven architecture. For instance, when a file is uploaded or modified in Blob Storage, it can automatically trigger an Azure function to process the file or initiate downstream workflows without manual intervention. In the case of Blue Sky, they could use Azure Functions to handle customer-uploaded documents like images or PDFs in Azure Blob Storage. So when a customer uploads a new file, an Azure function will be triggered to extract metadata, generate thumbnails, and move the file to different containers based on its type. By using the Blob Storage trigger in Azure Functions, this process becomes fully automated, requiring no manual intervention. This integration not only enhances efficiency, but also ensures that Blue Sky can scale its services seamlessly. As Blue Sky expands, it will also need to analyze vast amounts of customer and system data. By integrating Azure Blob Storage with Azure Data Lake, Blue Sky can efficiently store and analyze large datasets. Blob Storage can function as a data lake for storing massive amounts of unstructured data, such as logs, images, and streaming data. Azure Data Lake Gen 2 can also provide hierarchical namespaces and features optimized for big data analytics on top of Blob Storage. Blue Sky can also leverage Blob Storage to store log files and Azure Data Lake Analytics to query and analyze the logs to identify trends, system bottlenecks, and customer behavior. This seamless integration allows Blue Sky to process terabytes of data efficiently and at a low cost. Another valuable integration is the way Azure Blob Storage can connect with Azure Synapse Analytics, which provides a deeper insight into customer data. Azure Synapse is a powerful analytics service that combines big data and data warehousing capabilities. For example, Blue Sky could integrate with Azure Synapse to perform multidimensional data analysis, examining factors like time, customer segments, and product categories. It could also generate reports and develop predictive models to forecast future customer behavior. Synapse achieves this by accessing data from Blob Storage using Polybase, a data virtualization technology, allowing for fast and efficient querying without the need to move large datasets. This integration improves Blue Sky's decision-making process by providing real-time insights into customer activity, helping them refine and optimize their services. Another productive integration is between Azure Blob Storage and Azure Cognitive Services, which allows for the building of intelligent applications. Cognitive Services provides pre-built AI models for image recognition, speech processing, and natural language understanding, which can be used in conjunction with the data stored in Blob Storage. In the case of Blue Sky, they could store customer-uploaded images in Blob Storage and use Azure Cognitive Services Computer Vision API to analyze and tag these images automatically. For example, if a customer uploads a photo for an e-commerce platform, the image is sent to the Computer Vision API, which generates tags like shirt, blue, or cotton. These tags are then stored as metadata in Blob Storage for fast retrieval and search capabilities. This entire process is automated, which gives Blue Sky an edge in delivering enhanced customer experiences. Azure Blob Storage is also a critical component for training machine learning models. For instance, if Blue Sky wanted to develop a recommendation engine for its customers based on their interaction data, it could integrate Azure Blob Storage with Azure Machine Learning and use its existing datasets stored in Blob Storage to train machine learning models. Azure Machine Learning can read large datasets directly from Blob Storage to train models without the need to move data between services. Once trained, these models can be deployed to production, where they can access live data from Blob Storage for inference. This integration enables a seamless pipeline from data ingestion to model deployment, ensuring smooth scalability for large-scale machine learning workloads. Lastly, Blue Sky will need to protect its business data. To handle this, it can integrate Azure Backup with Blob Storage to provide a reliable and secure backup solution for virtual machines, SQL databases, and file shares. Additionally, by leveraging Blob Storage's redundant storage options, such as Geo-Redundant Storage or GRS, Blue Sky can ensure that backup data is stored across multiple regions, protecting it from potential data loss due to outages or disasters. Furthermore, features like immutable blob storage make backups tamper-proof, further strengthening the reliability of its disaster recovery strategy. In conclusion, Azure Blob Storage is a highly versatile and powerful solution that seamlessly integrates with a wide array of Azure services. These integrations enable businesses like Blue Sky Innovations to create scalable, efficient, and intelligent cloud-based applications tailored to their needs. By taking advantage of these capabilities, organizations can enhance their storage infrastructure, drive innovation, streamline operations, and significantly improve overall efficiency.
Previously, you became familiar with the capabilities of Azure Monitor, a service that makes it easier to collect relevant data about the health and performance of your Azure resources. However, most of this data pertains to individual parameters and instances. So what can it tell you about the bigger picture? There's no need to continue guessing, because Azure has a solution to make such data more meaningful. In this video, you'll explore the fundamental concepts of Azure Log Analytics, a core component of Azure Monitor, designed to provide deep insights into your Azure environment. As you may already know, when you enable Azure Monitor, an Azure Log Analytics workspace is automatically created to store and analyze your log data. However, if you ever need to create a dedicated log analytics workspace for specific resources or custom monitoring needs, you're in the right place to learn more. But first, let's start with the basics. A log analytics workspace serves as a central repository for all the data collected from your Azure resources, non-Azure systems, and applications. The workspace stores this data in tables that are created automatically or can be customized based on the data model you define. Each log analytics workspace contains multiple tables to store the monitoring data collected from Azure and non-Azure resources. Tables are automatically generated for Azure data, but you can create custom tables to store specific log data from external systems or applications. Table management settings allow you to control access, define data models, and manage the retention and cost of the data stored within each table. When it comes to data retention, Log Analytics allows you to retain data in two distinct states. Interactive retention is the default state where data can be retrieved, visualized, and queried. It remains available for real-time monitoring and analytics. Long-term retention refers to data that can be retained for up to 12 years in a low-cost storage tier. When necessary, you can easily retrieve specific data from long-term retention without moving it to external storage. For accessing data within a Log Analytics workspace, permissions are controlled by roles, of which there are two general types. You can assign built-in roles with predefined permissions, or create custom roles to manage who can view, query, and analyze log data. You can also allow users to access data collected from Azure resources by granting them permission to those resources. For managing and optimizing your Log Analytics workspace, Azure provides tools through Workspace Insights. These insights offer a comprehensive view of your workspace's performance, health, ingestion rates, and data queries, enabling you to efficiently monitor and optimize your workspace's operations. Another important thing to know about log analytics is what data is collected and where it comes from. This includes diagnostic logs and performance metrics from Azure virtual machines, logs and metrics from Azure services such as Azure SQL Database and Application Gateway, and logs from non-Azure sources or external applications via REST API or custom data collection agents. Now that you know about the core concepts of log analytics, let's discuss how you can create your own dedicated log analytics workspace. While your initial log analytics workspace is created when enabling Azure Monitor, you can create additional workspaces if required by following these steps. First, navigate to the Azure portal by typing portal.azure.com into your browser's address bar. In the search bar, type Log Analytics Workspaces and select the service. Select Add, then choose your subscription and resource group and assign a unique name to your workspace. Next, select the region where the workspace will reside and configure the pricing tier and data retention settings based on your monitoring needs. Finally, select Review and Create to finalize and set up your workspace. This dedicated workspace provides the flexibility to manage log data for specific resources or departments, ensuring data separation and compliance. Before wrapping up, one more detail to cover is how to run queries in Azure Log Analytics. Kusto Query Language, or KQL, is used to retrieve and analyze data in Azure Log Analytics. It enables you to filter, aggregate, and visualize data to gain insights into resource performance and system health. Use cases for queries include monitoring CPU and memory usage of Azure virtual machines, analyzing web application failures by querying custom logs, and tracking performance metrics such as disk I/O and network latency. In this video, you learned about the key concepts behind Azure Log Analytics, including the role of a log analytics workspace, the sources for data collection, and how to run queries. This solution provides robust capabilities to store, manage, and analyze log data from various sources, whether they are Azure native or external. By mastering the fundamentals, you gain deep visibility into your resources' health and performance, ensuring efficient monitoring and proactive management of your Azure environment. You recently learned that an Azure Log Analytics workspace compiles log data collected from Azure and non-Azure resources into one place, ready for analysis and other tasks. At the same time, this produces a vast amount of information that can be difficult to navigate without tools or a structured approach. That's why in this video, you'll learn to level up your efficiency with core skills for writing and executing queries in Azure Log Analytics. You'll do this using Kusto Query Language, or KQL, which, as you might recall, is a language for retrieving and analyzing log data. You'll also find out how to filter data, apply multiple conditions, and even visualize data using charts and tables. Note that if you've already enabled Azure Monitor, then a Log Analytics workspace was created automatically, and you can work from it. But if you don't have one, create a workspace before proceeding. To begin, enter the following address into your web browser address bar, aka.ms/LA-demo. This opens the Log Analytics interface where your queries will apply to all the data in the chosen workspace. You'll find the current query scope in the upper left corner, indicating the workspace being queried. In your own environment, you can adjust this scope to focus on specific resources. The Tables tab on the left side of the screen provides a list of all available tables in your workspace. These tables contain various types of data, which are grouped by default under Solutions, but you can filter or change the grouping as needed. For example, if you select the App Requests table under Log Management, you'll find a schema of the columns and their data types. Before running a query, you can preview some data to confirm it matches your expectations. To write your first query, double-click on the App Requests table or hover your cursor over it and select Use in Editor to add it to the query window. This is the simplest form of a query and will return all records in the table. To execute the query, select Run or press Shift plus Enter. Once the query runs, the output pane displays the results. The number of records retrieved is shown in the lower right corner, with a maximum limit of 30,000 records in the Log Analytics portal. Next, let's talk about how you can filter the results of a query. By default, your query will return results from the last 24 hours. You can adjust the time range by using the time range drop-down list at the top of the screen or by adding a where clause to your query. For example, selecting last 12 hours in the drop-down will modify the results without changing the query itself. To further narrow down your results, you can add multiple filters. For instance, you can filter by a specific request name if you're analyzing application requests. To do so, go to the Filter tab on the left, select Load Old Filters, and apply the relevant filter conditions. For example, filter the results for requests to the GetHome/Index endpoint. After applying the filters, select Run to see the updated query results. After a query, you interact with the results by expanding rows to see all column values or by sorting the results based on a particular column. For example, sorting the duration MS column allows you to easily check the requests that took the longest time, expressed in milliseconds. Additionally, you can filter the data directly from the results pane. Say you want to filter only records where duration MS is greater than 150 milliseconds. You can set this condition interactively without editing the query. If you'd like to search through the query results, you can use the search box at the top right of the results pane. To try it out, enter Chicago in the query results search box and select the arrows to find all instances of this string in your search results. To better visualize your data, you can reorganize and summarize the data in the query results based on your needs. Start by selecting columns to the right of the results pane to open the column sidebar. In the sidebar, you'll find a list of all available columns. Drag the URL column into the Row Groups section. The results are now organized by that column, and you can collapse each group to help you with your analysis. This is like adding a filter to the query, but instead of refetching data from the server, you're processing the data your original query returned. This method helps to quickly analyze a set of records as part of the interactive analysis. One more trick for data visualization is creating a pivot table. By selecting Pivot Mode from the column sidebar, you can summarize data based on specific fields like URL and duration MS. For instance, to evaluate page performance, you can view the total duration for each URL and identify which pages have the longest load times. In this video, you've explored the essential features of Azure Log Analytics and how to query log data using the Kusto query language. You've learned how to open Log Analytics, navigate tables, write simple queries, and apply filters to refine your results. By interacting with the query results, using sorting and filtering, and even creating pivot tables, you now have a foundational understanding of how to effectively analyze log data in Azure Monitor.
Nice job reaching the end of this module. You've made fantastic progress and gained valuable skills in configuring storage accounts with Azure Blob Storage. This module has equipped you to not only set up and optimize storage, but also seamlessly integrate it with other Azure services. By getting here, you should now be able to describe Azure Blob Storage fundamentals and optimization techniques, identify scalability and performance considerations for selecting Azure storage account types, list different data archiving strategies used in Azure Blob Storage, and run basic queries in Azure Log Analytics to extract meaningful data and gain insights. Now, before you take on the module quiz, let's recap what you learned to ensure that you're ready. You began by exploring key Azure storage concepts, learning how Azure Storage plays a vital role in Azure networking. You learned about the core principles behind Azure Storage data services, including the main components, storage types, and how data management works. You then gained a solid understanding of the different types of Azure storage accounts and when to use each one based on specific needs. Plus, you walked through the steps of configuring Azure Blob Storage, one of the most crucial parts of Azure Storage. Next, you explored the various types of managed disks available in Azure and learned best practices for optimizing performance, reliability, and security when setting up Azure storage solutions. You followed this with the technical exploration of Azure storage account types, focusing on advanced features, scalability considerations, and performance nuances. You then examined advanced security measures, which gave you a solid grasp of security protocols and best practices for managing Azure Storage accounts. Following this, you reviewed the steps required for configuring Azure Table Storage and discovered how it's applied to structured data. Additionally, you explored replication options for Azure Storage accounts to ensure data durability and availability. On the performance side, you discovered optimization strategies for Azure Blob Storage, learning how to maximize efficiency. You also studied effective data archiving strategies using Azure Blob Storage to ensure long-term data preservation and accessibility. You later learned how Azure Blob Storage integrates with other Azure services, opening up diverse application possibilities. You also covered security considerations specific to Azure Blob Storage to ensure your data stays protected with proper access control and data integrity. Finally, you explored Azure Log Analytics and gained a stronger understanding of its role in providing deep insights into your Azure environment. To that end, you unpacked a tool that enables you to navigate the data in the Log Analytics workspace, Kusto Query Language or KQL. Recall that KQL is a language for retrieving and analyzing log data. You were guided to perform key operations such as accessing a data table, running a query, filtering query results, and visualizing query results. You also found that when it comes to ingesting log data, Log Analytics isn't limited to just Azure resources. It can also collect telemetry from non-Azure systems through APIs. One such API is Azure Monitor Logs Ingestion API, which is able to send logs in custom data formats and handle large volumes of data. There's also Data Collector API, which is compatible with numerous sources and integrates well with automation tools and scripts. Throughout this module, you engaged with videos, readings, and activities that have built a strong foundation in Azure Storage and Azure Log Analytics. With this essential knowledge, you're now more prepared to make informed decisions for your organization, bringing you closer to becoming a cloud support professional. The next step is to take the module quiz. If this video highlighted any areas you'd like to revisit, take some time to review the relevant videos, readings, or activities to ensure you're fully prepared. Best of luck. In any data-driven organization, having a reliable backup strategy is like having an insurance policy for your data. It protects your business from unexpected disasters and keeps everything running smoothly. Just as you wouldn't drive a car without insurance, a company shouldn't operate without a backup plan. Backup plans are crucial for ensuring business continuity, safeguarding against data loss, and protecting the integrity of sensitive information, especially in modern cloud-based environments like Microsoft Azure. In this video, we'll explore practical techniques that companies can adopt to strengthen their backup frameworks and adapt to the business world's changing demands. By exploring real-world applications and the latest industry trends, you will gain the insights needed to enhance your data protection strategies and strengthen your organization's resilience against any potential challenges. Let's begin with the basics. When it comes to backups, most people are acquainted with the standard concepts of full, incremental, and differential backups. These concepts are the foundation of any backup strategy, but understanding their limitations and how they integrate with larger data protection strategies is crucial for scaling backup operations. For example, while a full backup is often the first step, it is impractical to run continuously due to the time and resources required, especially in a cloud environment. Incremental backups, which only save changes since the last backup, significantly reduce resource usage, but they need an efficient and well-maintained catalog to avoid data restoration issues. Differential backups sit between these two, balancing resource efficiency with restoration speed. In practice, businesses need to strike the right balance between these methods. For instance, a corporation with terabytes of data stored in Azure might schedule a full backup once a month and run incremental backups daily. This minimizes the impact on cloud storage resources and ensures that recovery times remain within acceptable limits. One popular approach for safeguarding your data is the 3-2-1 backup rule, which remains relevant even in cloud-based environments. The widely recognized 3-2-1 backup rule advocates keeping 3 copies of data on 2 different media, with 1 copy stored off-site. However, applying this principle to modern, cloud-first environments like Azure requires adaptation. Traditional 2 media might refer to physical storage devices, but in the cloud, this could mean leveraging different regions or storage types within Azure. For example, Azure allows companies to use geo-redundant storage or GRS, which automatically replicates data across various geographical regions. While this satisfies the off-site copy requirement, businesses need to weigh the additional costs and potential latency in accessing these off-site backups. Companies that use Azure might take this further by adding redundancy at multiple levels. For example, a global corporation might store critical databases in locally redundant storage or LRS within a primary region while also using GRS for off-site redundancy. Meanwhile, less critical data could be backed up using Azure's Zone Redundant Storage or ZRS, which maintains backups across different availability zones within a region but doesn't incur the same costs as GRS. One of the most overlooked aspects of any backup strategy is the consistency model employed. Let's examine two of these types of models, application and crash consistent, a little closer. In the Azure environment, understanding the difference between application and crash consistent backups is vital for ensuring data integrity during recovery. A crash consistent backup captures the system's state at a specific point in time, like pulling the power plug on a server and capturing the state of all the data. While this might suffice for systems where data is infrequently written, it is risky for applications like databases where in-flight transactions could be lost. In-flight transactions refer to data changes or transactions that are actively being processed or written to a database or application at the time a backup is initiated. These transactions are not yet finalized or committed, meaning they haven't been fully saved or recorded in the system. On the other hand, application-consistent backups ensure that all in-flight data is properly completed and saved to the database, guaranteeing that the backup is complete and reliable. For example, a global financial company that relies on a database system in Azure SQL would likely require application-consistent backups to ensure that any backup taken reflects the database's valid state. This guarantees that when restored, the data will reflect the true operational state at the time the backup was taken, ensuring business continuity. Azure Backup offers options to configure both types of consistency, but for mission-critical workloads, application-consistent backups should be prioritized. This is particularly important in scenarios where the recovery point objective, or RPO, is very low, meaning that any data loss could have severe consequences for business operations. Disaster recovery, or DR, is another essential concept, yet a common mistake is treating backup and DR as entirely separate entities. In reality, an effective backup strategy is essential for disaster recovery, but the two must be tightly integrated. Azure's native backup solutions can be seamlessly integrated with Azure's Site Recovery, or ASR, allowing businesses to both backup and replicate critical systems in secondary regions. For example, a company that is reliant on uninterrupted operations might integrate its Azure Backup strategy with ASR to not only backup databases, but also ensure that VMs hosting the web applications are replicated in a secondary region. In the event of a failure in the primary area, the VMs in the secondary region can take over, ensuring continuity. This reduces downtime and prevents data loss, protecting revenue streams. However, how can businesses keep up with the growing scale and complexity of corporate data environments? This is where automating backup processes becomes crucial to ensure consistency, reduce human error, and optimize resource use. Azure's automation capabilities allow businesses to set up policies for automated backups, defining when and how different types of backups should occur. Using Azure Policy, companies can create guardrails that ensure compliance with their backup strategy across all departments. For instance, a policy might enforce the provision of daily incremental backups and weekly full backups for all production databases. Furthermore, Azure Automation can be used to schedule backups at non-peak times, ensuring minimal disruption to business operations. Consider a large multinational company with offices across multiple continents. Each office runs its own set of applications and databases, all hosted within Azure. Through backup automation, the company can ensure that each location adheres to the same backup policy without requiring manual intervention. This guarantees that all data is consistently backed up across regions, reducing the risk of localized failures. Lastly, effective backup strategies require continuous monitoring and adjustment. Azure offers robust monitoring tools through Azure Monitor and Log Analytics, which can provide insights into backup job performance and alert administrators to any issues or failures. By regularly reviewing these logs, companies can proactively address any gaps in their backup strategy. Take the example of a media company that produces large video files daily. By using Azure Monitor to track the performance of their backup jobs, the IT department can spot if incremental backups are becoming too large. This indicates that the full backups may not be efficiently capturing changes. Just as the car insurance policy shields you from unexpected disasters, an effective backup strategy protects your data by ensuring it can be restored quickly and seamlessly, minimizing business disruption. It's not merely about creating copies of data. It's about having the right measures in place to guarantee reliable restoration when it matters most. By moving beyond basic definitions and exploring more advanced concepts such as consistency models, automation, and integration with disaster recovery, companies can fully leverage Azure's backup capabilities. Imagine you've just expanded your small bakery into a full-scale operation with locations across the country. Initially, tracking inventory, recipes, and sales is manageable with basic tools. But as the business grows and the stakes get higher, you'll need a reliable system to ensure nothing slips through the cracks. That's where Azure Backup comes in. It acts like a digital safety net, safeguarding your data as your business scales. You're probably aware that Azure Backup is a cloud-based service that simplifies data protection while providing security, scalability, and cost efficiency. In this video, you'll learn how Azure Backup empowers businesses to manage data across various environments, from on-premises servers to cloud-based virtual machines. You'll see how it automates backup processes, integrates with disaster recovery or DR, and helps you select the right consistency models to meet your specific needs. Let's begin by exploring what Azure Backup offers. Azure Backup integrates seamlessly with Azure's ecosystem, offering a unified solution for backing up files, virtual machines, databases, and even on-premises systems. The service enables businesses to manage their backups using a centralized portal, reducing complexity and the need for separate siloed backup tools. Azure Backup has several key components, including Azure Backup for VMs, which allows users to backup entire VMs running in Azure. Businesses can protect both Windows and Linux-based VMs, configuring automated backup schedules that ensure system states and data are consistently protected. Azure Backup also offers support to databases hosted in Azure, particularly SQL workloads. This includes application-consistent backups, ensuring that the backup consists of all committed transactions, reducing the risk of data corruption. Azure Backup doesn't just focus on cloud-native services. Using the Microsoft Azure Recovery Services, or MARS agent, businesses can back up on-premises data directly to the cloud. This is especially useful for companies that maintain a hybrid environment where they need to ensure continuity for both on-premises and cloud resources. Lastly, containers have become increasingly popular in modern application deployment. Azure supports the backup of Kubernetes workloads through Azure Backup for Azure Kubernetes Service, or AKS. This service helps businesses safeguard stateless and stateful container data. Now let's look at how this plays out in the real-world scenario. Imagine a global retail company, Retail Sync, with physical stores in various regions and a platform hosted in Azure. The platform is supported by Azure VMs, while SQL databases manage real-time inventory tracking and customer transactions. Using Azure Backup, Retail Sync schedules automated VM backups to run during off-peak hours to avoid service interruptions. SQL database backups are also automated with point-in-time restore capabilities, ensuring that any incident affecting the database can be quickly mitigated by rolling back to a specific transaction point. This minimizes downtime and protects the integrity of financial transactions, even if a data corruption issue arises. Retail Sync also uses the MARS agent to back up data from its on-premises systems, which hold vital customer and inventory information. By leveraging Azure Backup's cloud-based capabilities, Retail Sync can ensure that all customer-facing services stay operational even if a part of the infrastructure fails. Businesses with mission-critical applications, such as financial services or e-commerce platforms, often require application-consistent backups to ensure no transaction data is lost. In the case of Retail Sync, application-consistent backups are crucial for protecting SQL databases. Without this level of backup, the retailer could risk losing critical inventory updates or customer orders in the event of a failure. Now let's discuss one of Azure Backup's key advantages: its ability to scale. As businesses grow, their data needs increase exponentially. Azure Backup provides a scalable solution that automatically adjusts based on data volume, eliminating the need for businesses to invest in additional hardware or complex infrastructure. Additionally, Azure's pay-as-you-go pricing model ensures that companies only pay for the storage and resources they actually use. For example, Retail Sync initially started with a few hundred gigabytes of data. Over time, as the business expanded, so did the amount of data that needed protection. Azure Backup is easily scaled to accommodate terabytes of data without requiring any changes to the retailer's backup strategy or infrastructure. This flexibility is critical for enterprises looking to avoid the limitations of traditional on-premises backup systems, which often require significant upfront investment. Another important aspect of backup strategies is how they integrate with DR. Azure Backup works closely with Azure Site Recovery, or ASR, to provide a comprehensive DR solution. While backups ensure that data is recoverable, ASR enables replication and failover of entire systems, minimizing downtime in the event of a major incident. In the case of Retail Sync, ASR could be configured to replicate the primary system to a secondary region. If the primary system experiences downtime, ASR automatically fails over to the secondary region, ensuring that customers can continue making purchases without interruption. The seamless integration of backup and disaster recovery in Azure provides a safety net for businesses relying on high availability. Lastly, Azure Backup ensures that data protection extends beyond just recovery. Built-in encryption ensures that backup data is secure both in transit and at rest. Additionally, features like MFA and RBAC allow businesses to tightly control who can access backup data and how it is managed. For Retail Sync, compliance with industry standards such as GDPR is essential. Azure Backup enables them to meet regulatory requirements by providing immutable backups and audit logs, which ensure that data cannot be tampered with after it's backed up. This level of security is crucial for businesses that handle sensitive customer data, as it helps mitigate the risk of data breaches and ensures adherence to legal requirements. Azure Backup offers businesses a comprehensive, scalable, and secure solution for protecting their critical data, whether it's hosted on-premises, in the cloud, or across both environments. By automating backups, supporting multiple consistency models, and integrating with DR tools, Azure Backup simplifies data protection and ensures business continuity. For companies like Retail Sync, the ability to protect and restore both cloud and on-premises data is vital to guaranteeing operational resilience and safeguarding customer trust. Backup strategies are critical for any organization aiming to safeguard its data and ensure business continuity in case of disasters. Companies, especially those with complex infrastructures, face various risks that could lead to data loss, ranging from hardware failures and human error to natural disasters or cyber attacks. To mitigate these risks, businesses need robust disaster recovery plans that include various backup methods. This video will explore key strategies that companies can leverage, including full, incremental, differential, and off-site backups, all within the context of maintaining a comprehensive disaster recovery solution. First, let's examine full backups, the foundation of data protection. This kind of backup involves copying the entire dataset from a system, regardless of whether the data has changed or not. This method ensures that businesses have a complete, standalone backup of their data, which can be restored independently of any previous backups. Full backups are typically performed on a regular schedule, such as weekly or monthly, depending on the size and importance of the data. Though full backups are straightforward, their main disadvantage is that they consume a significant amount of storage and can take a long time to complete, especially for companies with large datasets. In practice, full backups are often combined with other backup strategies like incremental and differential backups to reduce their frequency and optimize storage use. For example, a corporate IT department might schedule a full backup once a week while using incremental or differential backups in between to capture changes. This way, in case of data loss, a complete restore can be performed using the latest full backup as the baseline. Next are incremental backups, which are designed to address the storage and time limitations of full backups by optimizing storage and speed. Instead of copying all data, incremental backups only capture the files that have changed since the last backup, whether it was a full or an incremental backup. This approach reduces the amount of data being backed up, speeding up the process and minimizing storage needs. Incorporating incremental backups into a disaster recovery plan can significantly improve operational efficiency. Consider a corporate scenario where daily incremental backups are performed after a weekly full backup. For each day in the week, only the files that have been added, modified, or deleted since the previous day's backup are copied. When it comes time to restore data, the company would use the last full backup and each incremental backup in sequence until the most recent data is restored. One drawback of incremental backup is the potential complexity involved in the recovery process. To restore the data, every incremental backup must be applied in order, which can increase recovery time. However, the storage and speed advantages make incremental backups a valuable component in a well-rounded backup strategy. Last are differential backups, which offer a middle ground between full and incremental backups. Like incremental backups, they only copy data that has changed since the last full backup. However, unlike incremental backups, differential backups do not reset with each backup. Instead, every differential backup captures all changes made since the last full backup, regardless of how many differential backups have already been made. This characteristic makes differential backups faster than full backups, but slightly slower than incremental ones. They're also simpler to restore than incremental backups because only two backups are needed for recovery: the latest full backup and the most recent differential backup. For businesses, the trade-off between storage space and restore complexity is a key factor when considering differential backups. A common strategy is to perform full backups weekly, incremental backups daily, and differential backups midweek to ensure that both storage usage and recovery times are optimized. Imagine a corporate environment where the IT department runs weekly full backups every Sunday, incremental backups from Monday to Wednesday, and a differential backup on Thursday. If data loss occurs on Friday, the IT team could restore from the Sunday full backup and the Thursday differential backup, bypassing the need to sequentially apply each incremental backup from the week. This balances speed and simplicity, ensuring quick recovery in a disaster scenario. While full incremental and differential backups offer protection against data loss, they may not safeguard against more severe events like natural disasters or cyber attacks that affect the primary data center. This is where off-site backups come into play. Off-site backups involve storing copies of data in a different physical location or in the cloud. For example, an enterprise might store its full backups at a secondary data center located in another region. Or it might use a cloud service provider like Azure or AWS to store backups in geographically distributed locations. In the event of a localized disaster, such as a fire or flood that affects the company's main data center, off-site backups ensure that the business can still recover its data and resume operations. This approach is particularly critical for organizations with strict regulatory requirements or high uptime demands. A corporate company can take advantage of cloud-based backup services to automate the process of transferring full and incremental backups to an off-site location. By using Azure Backup or similar services, companies can configure policies to automatically store backups in multiple regions, ensuring compliance with disaster recovery and business continuity planning. For a corporate IT department, a single backup method rarely provides comprehensive protection. Instead, companies should adopt a combination of full, incremental, differential, and off-site backups to build a resilient disaster recovery plan. For example, an enterprise might implement the following strategy. Weekly full backups are stored both locally and in an off-site location. Daily incremental backups are performed to minimize storage usage and time. Midweek differential backups are used to ensure quicker recovery in case of failure. and all backups are automatically replicated to an off-site cloud provider, ensuring data is protected even in the event of a regional disaster. In this scenario, the IT team can recover quickly from any level of failure, whether it's a simple human error or a large-scale disaster affecting their primary data center. A well-designed backup strategy is essential for ensuring business continuity in the face of disasters. Full backups provide a complete baseline of data, while incremental and differential backups optimize the storage and speed of the backup process. Off-site backups further ensure data protection against large-scale disasters. Corporate organizations, especially those with complex infrastructure, can utilize these backup methodologies to maintain continuous operations and meet recovery time objectives in the event of an unforeseen disaster. By carefully selecting and combining these strategies, businesses can implement a robust disaster recovery plan that aligns with their operational needs and regulatory requirements. Backup compliance and security best practices are crucial for safeguarding an organization's data while adhering to regulatory standards. A well-executed backup strategy not only ensures data availability in the event of a disaster, but also complies with various regulations like the General Data Protection Regulation, the Health Insurance Portability and Accountability Act, and the Service Organization Control 2. In this video, we will explore these compliance requirements and discuss the best practices that businesses should adopt to ensure secure backup processes, focusing on encryption, access controls, and audit trails to protect data throughout its lifecycle. Data regulations impose specific requirements for handling sensitive information, including how data backups should be managed. Failure to adhere to these regulations can result in large fines and legal repercussions. For example, GDPR mandates that businesses protect the personal data of EU citizens, requiring secure storage, processing, and transfer mechanisms. Article 32 of GDPR outlines the need for encryption and regular testing of backup systems to ensure compliance and data safety. Backups must be managed to allow personal data to be restored in a timely manner in the event of an incident. Next, HIPAA governs the protection of health information in the US, requiring healthcare organizations to implement specific administrative, physical, and technical safeguards. For backup compliance, HIPAA stipulates that all backups containing health information must be encrypted and securely stored to prevent unauthorized access or tampering. Failure to do so could result in a breach of patient data, leading to heavy fines and reputational damage. Lastly, SOC 2 is a set of standards for organizations that handle sensitive customer data. It requires strict control measures, particularly when it comes to data backups. SOC 2 compliance focuses on data availability, integrity, and confidentiality, making encryption and secure access control key elements of a backup strategy. As the regulations suggest, encryption is critical for securing backups, whether the data is in transit or at rest. By encrypting backup files, organizations ensure that sensitive information remains inaccessible to unauthorized users, even if the backup media is compromised. Data at rest encryption ensures that the data stored in backup files or storage systems is unreadable without the appropriate decryption keys. In cloud-based environments, this is typically achieved through managed encryption services, which allow organizations to encrypt data before sending it to the cloud or use cloud provider-managed encryption keys. AES 256 encryption is a standard widely regarded as secure for data at rest. On the other hand, data in transit encryption protects data as it moves between systems, especially when backups are transmitted over public networks. Secure transmission protocols like SSL/TLS are commonly used to encrypt backup data in transit, preventing interception by malicious actors. Another key component of compliance and security is implementing strict access controls to secure backup data. Not everyone in an organization needs access to backups, and limiting access to authorized personnel helps reduce the risk of data breaches. A well-defined access control policy ensures that backup data is only accessible to employees with the appropriate level of clearance. Role-based access control is one of the most effective ways to manage backup access. With RBAC, organizations assign roles to employees based on their responsibilities and restrict access to backup systems accordingly. For example, only IT administrators or compliance officers may have access to sensitive data backups, while regular staff may be restricted from even viewing the backup system. Additionally, multi-factor authentication adds another layer of security because users have to authenticate their identity using multiple factors, such as a password and a one-time code sent to their phone. This ensures that only authorized individuals can access the backup infrastructure, reducing the likelihood of unauthorized access. The third important component of compliance and security is audit trails, which record all activities related to backup processes. These logs provide a detailed account of actions taken on backup data, including when backups are created, modified, accessed, or deleted, and by whom. Backup audit trails help identify potential security threats or policy violations by tracking who accessed backups, when they were accessed, and what changes were made. If an unauthorized action occurs, organizations can quickly detect and respond to the incident, minimizing the risk of data loss or compromise. Regulatory compliance often requires regular audits of backup practices. GDPR, for example, mandates that organizations regularly test their backup systems to ensure that they function properly in case of an emergency. Having audit trails helps organizations demonstrate their compliance during regulatory reviews or internal audits. Best practices for backup security and compliance include adopting the 3-2-1 backup approach. This method advises maintaining 3 versions of data distributed across 2 different storage mediums, with one backup kept off-site. This strategy enhances both the accessibility and durability of backups in the event of a disaster. To meet compliance requirements and ensure that backups can be restored, businesses should schedule regular backup tests. These tests confirm the integrity and recoverability of backup data, helping organizations avoid nasty surprises during an actual disaster. And different regulations impose specific data retention requirements. For example, GDPR specifies that personal data should not be stored for longer than necessary. Organizations must align their backup retention policies with these requirements to avoid compliance issues. In summary, backup compliance and security best practices are essential for businesses that handle sensitive data. Regulations require robust encryption, strict access controls, and comprehensive audit trails to protect data backups. By following these best practices, organizations can ensure that their backups are secure and compliant, safeguarding both their operations and their reputation. By now, you've probably realized that Azure file shares are like an office filing cabinet for all your important documents and files, but without the space limitations. With Azure Files, you get 24/7 access from anywhere, offering cloud-based storage that uses familiar protocols like SMB or server message block. It's an ideal solution for businesses looking to move from traditional file servers to a more scalable cloud-based system. However, just as you wouldn't leave a real filing cabinet unlocked, you need to protect your digital files. That's why setting up backups is essential to safeguard your data from accidental deletion, corruption, or loss. In this video, we'll walk you through setting up backups for Azure file shares step by step. You'll learn how to use the Recovery Services Vault, configure backups, and monitor their health with best practices for keeping your data secure and your backup processes efficient. Let's begin with the foundation of any Azure backup strategy, the Recovery Services Vault, which acts as the storage location for all your backups. The following steps will guide you through setting up a Recovery Services Vault for Azure file share backups. Start by opening the Azure portal and in the search bar, type Recovery Services Vault. Now select Create to add a new vault. Here, you can provide a meaningful name, choose your subscription, and select an appropriate resource group. You then select the Azure region closest to where your file shares are located. This is important for minimizing latency during backup and restore operations. Now select Review plus Create at the bottom. After verifying details, click Create to set up the vault. With the Recovery Services Vault created, it's now ready to manage and store backups for your Azure file shares. This vault will also give you access to monitoring tools to track backup health and performance. Now that you have the Recovery Services Vault ready, the next step is to enable backup for your Azure file shares. This process links your file storage with the backup service. Start by navigating to your Recovery Services Vault and select the Backup option from the top menu. Next, under the Where is your workload running section, select Azure. And under the What do you want to backup section, select Azure File Share. Then select the Backup option. At this point, your infrastructure is ready to support Azure File Share backups. The next step is to associate specific file shares with the vault for ongoing backup. To get started, you need to backup your Azure File Share to a connected storage account. The first step is to register this storage account with the Recovery Services Vault, which is essential for protecting the files stored within it. Start in the Configure Backup section and select your storage account. Next, select the storage account from the list and click OK to register it with the vault. Once the storage account is registered, you'll be able to choose individual file shares for backup. After defining the backup policy, the next step is to select which file shares should be backed up. Azure allows you to back up specific file shares rather than the entire storage account, offering flexibility in data protection. You do this by opening the Recovery Services Vault, then go to Protected Items and select Backup Items. From there, navigate to Azure File Shares. Now select Add and select the storage account where your file shares reside. Next, choose the file shares you want to back up from the list. For example, in a corporate scenario, you might choose to back up file shares used by the finance and HR departments separately, depending on their specific data retention needs. This process ensures that your critical file shares are protected, while non-essential shares that don't require backup can be excluded, improving efficiency. Now it's time to set up backup policies to determine when backups are performed, how often they occur, and how long they're kept. With Azure Backup, you can create custom policies for each file share, enabling you to balance your retention needs with cost and storage efficiency. You start in the Recovery Services Vault section by selecting Backup Policies under Manage and selecting Add. Now choose to create a new policy specifically for Azure file shares. Next, define the backup frequency. Most businesses recommend daily backups. However, depending on the criticality of the data, some may prefer multiple backups per day. Now it's time to configure the retention policy. For example, you might want to retain daily backups for 30 days, weekly backups for 3 months, and monthly backups for a year. Select Create to configure the policy. Then associate the file share with the policy to apply it to your Azure file shares. This is especially useful in industries with long-term compliance requirements such as finance or healthcare. You can apply the backup policy that you configured earlier to these file shares. Finally, click Enable Backup to initiate the backup process. This step ensures that backups are scheduled and stored based on your business requirements, helping to protect critical data while managing storage costs. After configuring your backups, the final step is to monitor them to ensure everything is running smoothly. Azure Backup provides detailed logs and reporting for all backup operations, helping administrators stay informed. You do this by navigating to your Recovery Services Vault, selecting your vault, and going to the Backup Jobs under the Monitoring section. Here you'll see the status of all backup jobs, including success, failure, and in-progress backups. To manually trigger a backup, navigate to Backup Items and then Azure File Shares, select the file share and click Backup Now. If a file share needs to be restored, navigate to Backup Items, Azure File Shares, select the file share and click Restore Share on the right-hand side. When restoring a file share, Azure Backup provides options for restoring to the original location or a new file share, allowing you to recover data without overwriting the current version. For businesses, regular testing of the restore process is a best practice. Scheduling restore drills quarterly ensures that backups are functioning as expected and that data can be recovered efficiently during an actual disaster. Configuring backups for Azure file shares is an essential part of any business's data protection strategy. By following these steps, setting up a Recovery Services Vault, registering storage accounts, configuring policies, and monitoring backups, you can ensure that your file shares are protected against accidental deletion, corruption, or loss. For corporate environments, Azure's scalable and flexible backup solutions provide a robust way to safeguard critical files without the complexities of traditional file servers. Backups play a vital role in ensuring data integrity and availability, especially in today's modern cloud environments. In Azure, configuring folder backups effectively is essential for organizations to safeguard their valuable data while balancing performance and cost efficiency. Consider Contoso Limited, a mid-sized company managing sensitive financial information across multiple departments. As Contoso transitions its operations to Azure, it faces the challenge of developing a folder backup system that not only protects its critical data, but also enhances system performance and controls expenses. The company aims to avoid unnecessary backups of non-essential data like temporary files or logs while maintaining its focus on critical business information. One of the initial steps Contoso should take is to establish a reliable backup system. A key approach to achieving this is by maintaining a clear and well-organized folder structure. A well-thought-out folder structure makes it easier to configure backups, locate data, and reduce redundancy in backup operations. In Contoso's case, the IT department decided to group files by department, such as finance, marketing, and sales, within Azure file shares. To further streamline the process, they implemented a tiered folder structure for each department, categorizing data into critical, sensitive, and general folders. This structure helps define the priority and frequency of backups. For instance, files in the critical category may require daily or hourly backups, while general data may only need weekly or bi-weekly backups. A clearly defined folder structure enables IT administrators to easily apply specific backup policies to different folder tiers, isolate high-priority files for more frequent backups, improving efficiency, and simplify restoration processes by making it easier to locate and recover the needed files. Azure Backup provides native tools for managing folder backups, making it easier to manage complex folder hierarchies and set differential backup policies based on the folder category. It's important to note that not all files need to be backed up. In fact, excluding certain files or directories can significantly reduce storage costs and improve backup performance. When configuring folder backups in Azure, it's essential to define precise inclusion and exclusion criteria. The IT team at Contoso identified that some non-essential directories, such as temporary files or logs that are periodically regenerated, do not require backups. While data categorized as critical or sensitive, including financial reports and client databases, were prioritized for more frequent backups to ensure data protection and minimize potential loss. Using Azure Backup's policy settings, Contoso's IT team configured exclusion filters for unnecessary files and applied retention rules to ensure that only critical data is retained for extended periods. This strategy minimizes backup times and reduces the overall storage footprint. Azure Backup also offers the flexibility to backup files based on metadata, such as file types or modification dates. Contoso leverages this feature to automatically exclude files older than 2 years from their general category folder, reducing the volume of data to be stored and improving the performance of incremental backups. Another vital consideration is backup scheduling. A well-defined schedule ensures that the most critical data is frequently backed up without overloading the system or creating unnecessary backups for less important data. For Contoso, the IT department established separate backup schedules for each folder category to ensure efficient data protection. Critical files are backed up every hour to minimize data loss and provide the highest level of protection in case of an incident. Sensitive files follow a daily backup schedule as they experience fewer changes compared to critical data but still require consistent protection. And general files are backed up weekly, which is sufficient given their low rate of modification and less critical nature. This approach allows Contoso to effectively balance data protection needs with resource optimization. Azure Backup allows you to configure these schedules flexibly, and Contoso benefits from using incremental backups. Incremental backups only store changes made since the last backup, reducing storage consumption and speeding up the backup process. Moreover, automation is key to ensuring backups happen consistently and without manual intervention. Contoso's IT team took advantage of Azure's automation features to configure backup jobs that run without human oversight. Azure Backup's built-in monitoring tools alert them of any failures or issues, providing confidence that their critical data is always protected. Determining how long backups should be retained is another crucial part of backup planning. Over time, storing too many backups can lead to unnecessary costs. On the other hand, deleting backups too soon may expose the company to risks in the event of delayed data corruption discovery. Contoso managed its backups by implementing a tiered retention policy. Critical files are retained for 6 months, with weekly full backups kept for long-term archiving. Sensitive files are retained for 3 months, with only monthly full backups stored for extended periods. And general files are retained for 1 month, with a focus on only retaining key operational data. Azure Backup supports flexible retention policies, allowing administrators to adjust retention times based on data importance and legal requirements. This flexibility lets Contoso optimize its storage costs while still meeting compliance requirements for financial data retention. Testing is a crucial part of various processes, including backup and restore operations, as it ensures data can be recovered during a crisis. At Contoso, the IT team conducts quarterly restore drills, stimulating data loss scenarios to practice restoring key files and verify the integrity of their backups. This proactive approach helps ensure that when a real need arises, they can quickly and efficiently recover data, minimizing downtime and avoiding potential data loss. Azure Backup includes a restore validation feature, which simplifies the testing process by providing comprehensive reports on the integrity of backups. This reassures Contoso's leadership that their business-critical data is secure and recoverable. By adopting a structured approach to folder backups in Azure, organizations like Contoso can ensure that their critical data remains safe and available while also optimizing for performance and cost. A well-organized folder structure, carefully defined inclusion-exclusion criteria, and tailored scheduling ensure that resources are used efficiently, reducing the load on both the system and storage capacity. The integration of retention policies and regular testing ensures that recovery processes can be swift and reliable even in the event of a failure. Azure's native tools offer flexibility and scalability for backup operations, empowering IT administrators to customize their backup strategy to meet the specific needs of their organization, just as Contoso Limited successfully did. Maintaining reliable backup configurations for file and folder data is crucial for data integrity and business continuity. For organizations like Contoso Limited, which leverage Azure for their cloud storage needs, efficient backup management can be the difference between seamless operations and disruptive data loss. In this video, you'll uncover strategies for monitoring and troubleshooting backup configurations in Azure, emphasizing practical steps to ensure data protection. Through the Contoso scenario, we'll explore how to set up alerts for backup job monitoring, review logs to diagnose issues, and address common problems that can arise. From setting alerts to notifying the IT team of failed backups, you'll discover how Contoso's approach to proactive monitoring can help maintain a solid backup strategy. Let's begin with proactive monitoring of your backup configurations, which is key to detecting and resolving potential issues before they escalate. Azure Monitor, integrated with Azure Backup, helps track metrics such as success rates, job duration, and storage consumption. Setting up Azure Monitor alerts is straightforward and customizable based on your company's needs. In the case of Contoso, they set up alerts to notify their IT team when backup jobs fail or exceed a predefined duration. These alerts are triggered based on log data provided by Azure Backup, allowing the team to act promptly before their service levels are affected. You can configure these alerts by navigating to either Azure Monitor or the Recovery Services Vault in the Azure portal for your created vault. Then, under Monitoring, select Alerts and then choose the Create Alert Rule option. In this section, Contoso's team selected metrics related to backup jobs such as backup job failed and backup job exceeded duration. Next, you can define an action group. Action groups specify what happens when an alert is triggered. Contoso sets their action group to send an email to their IT department, log the issue in a central system, and create a ticket for immediate investigation. Then, by leveraging dashboards in Azure Monitor, Contoso's IT department can visualize backup health and success rates in real time. This has significantly reduced the time between the detection of a backup issue and resolution. Alerts can also be integrated with other Azure services or third-party platforms to automate responses or escalate to higher-level support, ensuring that no alert goes unaddressed. Next, let's explore a fundamental aspect of troubleshooting backup issues: reviewing backup logs. Azure Backup generates detailed logs for each backup job, capturing the status, errors, and key performance data. Contoso Limited uses these logs to assess the performance of their backup jobs and investigate failures or incomplete backups. You can access these logs using the Azure portal, where detailed logs can be reviewed in the Azure Backup service within the Backup Reports section. This is where Contoso's team checks job histories to understand when and why a backup failed. Filters help identify patterns like frequent network issues or storage limitations. Or via PowerShell and Azure CLI, where Contoso can automate troubleshooting by using scripts to query logs across multiple storage accounts. This makes it easier to detect issues as the data footprint grows, helping with scalability as the company's data footprint increases across global offices. Lastly, Log Analytics is a feature within Azure Monitor. By exporting logs to Log Analytics, Contoso can perform advanced queries and visualize data, enabling them to review history and correlate with other events for better root cause analysis. Despite robust monitoring, backup configurations can still face occasional issues. Let's run through several backup issues that Contoso may face, including one of the most common issues Contoso faced was backup failures due to network disruptions. These failures were caused by network instability between their on-premises systems and Azure, often resulting in incomplete backups and data synchronization problems. Some steps Contoso can take to troubleshoot this are: by using Azure Network Watcher, you can monitor network latency and identify periods of network instability. When a backup failure is detected, the IT team correlates the failure time with network performance metrics. Configure Azure Backup to automatically retry failed jobs within a specific window, reducing manual intervention for transient network issues. And by adjusting data transfer settings, such as configuring throttling policies during peak hours, Contoso can minimize the impact of network congestion on their backups. Next, as Contoso scaled its operations, backup jobs began to fail due to insufficient storage space in the Azure file share. To avoid service disruptions, they implemented monitoring for storage capacity and adjusted their retention policies. For example, the IT team set up alerts to notify them when storage utilization exceeded 80%. This gave them enough time to expand the file share or clean up obsolete data. Additionally, Contoso optimized its backup retention policies to ensure that only the most critical data was retained for long durations. By reviewing usage patterns, they could delete older, redundant backups without risking compliance violations. Lastly, backup jobs can sometimes remain in a running state indefinitely. This is usually an indication of underlying infrastructure issues or timeouts during data transfer. To troubleshoot this, you can restart the Azure Backup service associated with the stuck job. Contoso's team could resolve the issue and resume backups without losing data. Additionally, an investigation of the Azure Backup job logs may reveal that certain data sets were taking too long to process due to large file sizes. To manage this, Contoso implemented data deduplication and compression, which improved the overall efficiency of the backup process. Effective monitoring and troubleshooting of file and folder backup configurations in Azure ensure data resilience and continuity for corporate environments like Contoso. By leveraging Azure's alerting, logging, and diagnostic tools, IT teams can promptly address potential issues and optimize their backup processes. Whether it's setting up proactive alerts, reviewing logs for root cause analysis, or resolving common problems such as network disruptions and storage limitations, these strategies allow organizations to maintain operational efficiency and minimize the risk of data loss. Keeping your VMs updated is a critical step in maintaining security, performance, and stability. Failing to apply updates not only leaves your environment exposed to vulnerabilities, but can also degrade system performance over time. This video will focus on the security benefits of regular updates, illustrated with real-world scenarios and best practices to ensure your VMs remain secure. Cyber attackers constantly search for vulnerabilities in outdated software and infrastructure. Vendors like Microsoft regularly release patches to fix these vulnerabilities. However, failing to apply updates leaves your system exposed to security risks. In 2017, the WannaCry ransomware attack exploited a vulnerability in the Windows Server Message Block or SMB protocol using an exploit known as Eternal Blue to spread the WannaCry ransomware worm. Once in a system, WannaCry would encrypt files, lock out users, and demand a Bitcoin ransom to decrypt the data. This exploit spread rapidly across networks, affecting both physical systems and virtual machines alike. Microsoft had actually released a patch 2 months before the attack, but many systems remained unpatched, leaving them vulnerable. The widespread impact, which affected sectors from healthcare to financial services, underscored the critical importance of timely patch management and security updates for all systems, including VMs, to mitigate the risk of such attacks. Another consideration when it comes to updates is compliance requirements. Organizations often need to comply with security standards like GDPR, HIPAA, and SOC to protect data privacy, integrity, and security in systems. Regular updates are crucial for maintaining compliance, as most regulations require systems to be protected against known vulnerabilities. Therefore, establishing a robust update policy that ensures security and compliance with legal and regulatory requirements is best practice, reducing the risk of penalties and security risks. Furthermore, updates often include performance enhancements that improve the efficiency and speed of your systems. This helps maintain security and stability under heavy workloads. For example, updates might address memory management optimizations that prevent memory leaks, which could otherwise lead to VM crashes or resource exhaustion vulnerabilities. Additionally, updates can include CPU optimizations to avoid inefficiencies that attackers might exploit to disrupt service. Network performance improvements are another focus, helping to reduce latency and ensure resilient access, which is particularly beneficial in environments facing high traffic or potential network-based attacks. Let's examine some specific risks of skipping updates a little closer. First, without regular updates, systems become increasingly vulnerable to known exploits. As exemplified by the WannaCry attack, hackers can use these unpatched vulnerabilities to gain unauthorized access or disrupt operations. An example is a financial organization that suffers a data breach because it delayed patching a critical vulnerability in its web server, exposing sensitive customer data. Second, systems that aren't regularly updated may experience increased instability, resulting in downtime, crashes, or other performance issues. System instability from outdated software increases the chances of exposing unresolved bugs that attackers could exploit, potentially gaining unauthorized access to sensitive data. For instance, an unpatched VM operating system may become unresponsive during high-demand periods or introduce security loopholes that hackers can use to disrupt operations, risking data loss and revenue impact. Lastly, delaying updates can prevent your systems from leveraging new features and enhancements that improve functionality and security. For example, by delaying updates, you may miss out on important improvements such as enhanced virtual machine management tools, new security features, or more efficient resource allocation. Automating the update process ensures that your systems remain secure without requiring constant manual intervention. Previously, the Azure service that provided automation capabilities was Automation Update Management, but it was replaced with Update Manager in September 2024. Azure Update Manager offers improved insights into update compliance, simplifies update scheduling, and provides enhanced features for managing operating system updates across cloud and hybrid environments. Although some companies continue to migrate from Azure Automation Update Management to Azure Update Manager, let's focus on Update Manager for now. Let's discuss some best practices to follow when it comes to updates. You should ensure that critical and security updates are prioritized while non-critical updates are scheduled for off-peak hours. Next, regularly monitor and audit your VMs to ensure that they are fully patched. Microsoft Defender for Cloud provides comprehensive security monitoring for VMs, including missing updates, and provides actionable recommendations to help you stay protected. You can also use Azure Policy to enforce update compliance across all your subscriptions. Even with well-managed updates, unforeseen issues may occur. For critical workloads, a failover plan ensures minimal disruption. Azure Availability Zones and Availability Sets ensure critical workloads remain operational during updates. Availability zones are physically separate locations within an Azure region. Placing VMs across zones can protect against data center level failures. If one zone goes down, the workloads in other zones remain operational. On the other hand, availability sets organize multiple virtual machines within a single data center, distributing them across separate fault domains and update domains. Fault domains place VMs on distinct physical hardware, while update domains stagger updates across different groups. This design helps to minimize disruptions, as updates are only rolled out to one domain at a time, ensuring continuous availability. You can also leverage Azure Site Recovery to create failover solutions that minimize downtime during maintenance windows. Maintaining regular updates for virtual machines is key to ensuring a secure, compliant, and efficient Azure environment. By automating updates, leveraging Azure tools, and implementing best practices, you can protect your infrastructure from vulnerabilities and ensure continuous system performance. As discussed, regular updates are essential. Now let's examine Azure's automated patching process, focusing on how Azure Update Manager streamlines update deployment. Additionally, we'll discuss how automatic VM guest patching provides further automation to keep VMs secure without manual input. Azure's patching system is designed to automatically manage operating system updates for virtual machines, ensuring that your infrastructure remains secure and up-to-date with minimal manual input. Understanding how Azure handles patching will help you make informed decisions about configuring and optimizing your update process. Azure prioritizes updates based on their importance. Updates often include feature improvements, performance enhancements, and bug fixes. These contribute to overall system stability. However, security patches are viewed as the most critical updates aimed at fixing vulnerabilities and safeguarding your environment. By automating security updates, Azure ensures that the most critical patches are applied promptly, minimizing the risk of exposure to vulnerabilities. Azure Update Manager centralizes the process of scheduling, deploying, and tracking updates across both Windows and Linux VMs. Through a unified interface, it allows administrators to schedule updates. Administrators can create regular maintenance windows to ensure updates are deployed during non-critical hours, reducing the risk of disruption to production workloads. Secondly, it assesses compliance by continuously monitoring the patch status of your VMs. This ensures that all critical patches are applied and you're alerted to any non-compliant machines. While Azure Update Manager offers robust control over the update process, automatic VM guest patching takes automation a step further, making the patching process even more seamless. This feature is specifically designed to automatically install critical updates on your virtual machines, ensuring they remain secure. Automatic VM guest patching ensures that virtual machines receive critical updates as soon as they're available without requiring custom scheduling or manual patch management. Optional updates, feature enhancements, or non-security patches are excluded from the critical update process, allowing administrators to retain control over those updates. Additionally, based on Azure's understanding of your VM's activity, patches are applied at a time that minimizes potential disruption. This ensures that patching does not interfere with your operations. Automatic VM guest patching has several benefits. First and foremost, it enhances security. By automatically applying critical patches, Azure reduces the window of exposure to known vulnerabilities, making infrastructure more resilient to security threats. The second is reduced administrative overhead, as administrators no longer need to manually track and apply critical security updates for each VM. This reduces the time spent on patch management. And lastly, automatic guest patching is enabled by default for new virtual machines, meaning you can benefit from this feature without additional setup. However, some configuration is still required for comprehensive patch management. Azure provides various tools and settings for controlling when and how updates are applied to virtual machines. This brings us to patch orchestration, which allows administrators to define the specific timing and sequence of patches to ensure updates align with operational needs and avoid disruptions. When creating a VM via the Azure portal, you can configure patch orchestration modes under the Management tab. This setting is available for both Linux and Windows virtual machines, giving you control over how patching is managed within your environment. Even with automatic patching in place, it's essential to maintain visibility over your VM's patch status. Azure Update Manager, with its seamless integration into Azure Monitor, provides a suite of tools that help administrators monitor and ensure patch compliance across all VMs. This integration enables in-depth reporting, alerting, and monitoring features, allowing administrators to track which patches were applied, when they were applied, and whether any issues occurred during the process. For example, it provides real-time compliance assessments for your virtual machines, ensuring that all required patches have been applied. This centralized view helps you track the patch status of all VMs, whether they are in Azure, on-premises, or in other cloud environments. Furthermore, through Azure's reporting tools, you can generate detailed reports on patch compliance and receive alerts for any machines that are non-compliant or have failed to apply updates. This allows you to quickly address any issues before they pose a risk to your environment. If a critical update fails or a VM falls out of compliance, Azure Update Manager can notify you immediately, ensuring that your team can take swift corrective action. It also provides intuitive dashboards that display the patch status of all VMs at a glance, allowing for quick identification of issues. The best approach to patch management often involves combining Azure Update Manager and automatic VM guest patching. Here are a few best practices to follow. Firstly, you should enable automatic guest patching to ensure that critical security updates are applied automatically. This reduces the risk of vulnerabilities while minimizing manual oversight. Secondly, use Azure Update Manager to schedule updates for non-critical patches and performance improvements during maintenance windows that suit your operational needs. This gives you control over less urgent updates while ensuring business continuity. You should also regularly review your patch compliance reports and take advantage of Azure's alerting system to address any non-compliant VMs. Proactive monitoring ensures that your environment remains secure and up-to-date. In summary, Azure's patching ecosystem, which includes Azure Update Manager and automatic VM guest patching, provides a comprehensive and automated solution for maintaining the security and stability of virtual machines. While Update Manager gives you centralized control over scheduling and compliance tracking, automatic guest patching ensures that critical security updates are applied without manual intervention. By using both tools together, you can minimize risk, reduce administrative overhead, and keep your VM secure with minimal disruption. Backing up virtual machines or VMs in the cloud is crucial to an organization's data protection and disaster recovery strategy. Imagine a company like TechCorp that relies on its Azure-based virtual infrastructure. Data protection and disaster recovery are vital to ensuring uninterrupted service for TechCorp. A well-designed VM backup strategy plays a key role in safeguarding operations, controlling costs, and meeting regulatory requirements. Azure provides a range of backup solutions, each tailored to specific recovery objectives, storage efficiencies, and business needs. In this video, you'll discover how TechCorp strengthens its data protection using 3 essential Azure backup strategies: snapshot-based, incremental, and image-level backups. From using snapshots for quick restores before major updates to applying incremental backups for storage efficiency and application consistency, and finally to deploying image-level backups for complete disaster recovery of critical systems. By leveraging these techniques, you'll learn how to build a resilient backup strategy that ensures seamless continuity for your organization. Let's kick off with snapshot-based backups, which are one of the simplest and fastest ways to capture the state of a VM at a particular moment. A snapshot takes a copy of the VM's disk and saves it to Azure, which is especially useful for short-term backup scenarios, such as before deploying system updates or software patches. However, snapshots are not full backups. They do not provide application consistency, meaning that the captured data might not include in-memory processes or transactions. For example, TechCorp uses snapshot-based backups to quickly create restore points before their IT team performs major system upgrades. These snapshots allow them to roll back changes in case the upgrade results in system instability. While this approach is useful, it's not ideal for long-term data retention, and TechCorp needs to supplement it with other methods. In Azure, you can create snapshots directly from the Azure portal, and they're stored as page blobs in the storage account. Snapshots provide a fast, easy way to restore a VM to a previous state. Still, they should not be relied upon as the primary backup strategy due to limitations in long-term retention and consistency. For short-term or pre-update protection, however, they serve as an effective safeguard. Next are incremental backups, which offer an efficient method for saving only the data that has changed since the last backup. This significantly reduces the amount of storage required and minimizes backup time. Azure Backup, for instance, uses incremental backup technology to create recovery points without duplicating the entire dataset each time a backup is run. TechCorp, which handles significant amounts of customer data, including databases and logs that change frequently, found this approach to be essential. Rather than performing full backups each time, which would be costly in terms of storage and time, TechCorp relies on incremental backups. Their backup system captures only the differences between the last backup and the current state of the VM, thus optimizing storage use and reducing network traffic. With incremental backups, Azure also ensures application-consistent backups for both Windows and Linux VMs by using the Volume Shadow Copy Service, or VSS, in Windows and pre-post scripts in Linux environments. This means that VMs backed up using this method can be fully restored with data consistency at the application level, which is critical for database-heavy applications. The last approach is image-level backups. These involve creating a complete backup of a VM, including the operating system, configuration files, and data volumes. This strategy is often used when an exact replica of a VM needs to be captured and fully restored in case of catastrophic failure, or to spin up identical environments for development, testing, or migration purposes. For example, TechCorp uses image-level backups to replicate their mission-critical VMs across different Azure regions. This allows them to have a hot standby environment ready for disaster recovery purposes. Since image-level backups store the entire VM, including the OS and settings, TechCorp can confidently recover quickly from any major failure, minimizing downtime. However, image-level backups consume more storage and can take longer to complete compared to incremental backups. They are best suited for use cases where an entire VM, including all settings and applications, must be captured and replicated. But how do you determine which backup strategy best fits your organization? For companies like TechCorp, this decision involves evaluating factors such as recovery time objectives, or RTO, the recovery point objectives, or RPO, the cost, and the criticality of their workloads. For example, snapshots are ideal for temporary backups, such as before system upgrades, but they are limited for long-term retention and may lack consistency for applications that require in-memory data. While incremental backups provide an efficient, scalable option for frequent backups of production systems, especially for databases or systems with high transaction rates, they are best for maintaining data consistency while reducing storage costs. And image-level backups are most suitable for disaster recovery scenarios where full VM restoration is required. They ensure that an entire system, including the OS, is recoverable in the event of a failure. However, for many organizations, a hybrid backup strategy that combines multiple approaches often proves to be the most effective solution. For instance, TechCorp might employ snapshots for short-term protection, incremental backups for daily operations, and image-level backups for critical systems requiring full disaster recovery. By combining these strategies, TechCorp can minimize costs while maximizing data protection. Snapshots give them quick rollback options, incremental backups reduce the storage footprint for frequent backups, and image-level backups ensure the ability to recover entire VMs when needed. This layered approach allows TechCorp to meet both its operational needs and compliance requirements. Azure's flexibility through services like Azure Backup makes it easy to configure and manage these different strategies. IT administrators can set policies to automate incremental backups, while critical systems can be protected using full image-level backups, all within a single unified platform. Azure offers a flexible suite of options for virtual machine backups, enabling organizations to select the most suitable strategy for their unique needs. Snapshot-based, incremental, and image-level backups each bring distinct benefits, and when combined, they provide comprehensive protection across diverse workloads. For companies like TechCorp, leveraging Azure's backup solutions ensures data integrity, reduces downtime, and optimizes costs. The key is to understand your organization's specific requirements and customize your backup approach accordingly, enabling fast recovery from disruptions and maximizing both storage and backup efficiency. Maintaining virtual machines or VMs is crucial for organizations as it ensures effective backup strategies are in place to protect against data loss and reduce downtime. For example, imagine Brightwave Technologies, a company that relies on Azure VMs to power its services. For Brightwave, managing and securing data is like setting up a protective network for a city's infrastructure. Just as a city needs emergency protocols and resources to handle power outages, Brightwave requires a reliable backup strategy to protect its digital assets from unexpected disruptions. Through Azure, Brightwave has a scalable environment for managing VMs, but configuring backups is essential to keep its operations running smoothly and prevent costly data loss. This video will demonstrate how Brightwave Technologies sets up VM backups in Azure, illustrating how the company has built a comprehensive backup solution to ensure data resilience and maintain service availability even during unexpected events. Your first step is to sign in to the Azure portal. To do this, simply navigate to the Azure portal and enter your credentials. Once you're logged in, you'll have access to all your Azure resources, including VMs, and you can begin the configuration process. Now, let's create a Recovery Services Vault, which is required to store backups in Azure. You can create one by following these steps. Search for Recovery Services Vaults in the top search bar of the Azure portal, then click Create. Now select your subscription and choose the appropriate resource group. Next, enter a name for the vault and select the region where it should be stored. And lastly, click Review plus Create and then Create to finalize the process. This vault will serve as a central storage location for all VM backups in your environment, offering both security and redundancy. It is critical to ensure that the Recovery Services Vault is located in a region that aligns with your data residency or compliance requirements. Once the Recovery Services Vault is created, it's time to configure the backup policies, which are essential for defining the backup schedule and retention periods. You do this by, firstly, navigate to the Backup Policies section within the Vault under Manage. Now, click on Add to create a new backup policy and select Azure Virtual Machine. Now define the backup schedule by choosing the frequency and setting the time at which the backup job should start. Then you need to configure the retention settings based on your business requirements. This could be daily, weekly, monthly, or yearly retention. You should consider longer retention periods for critical data, as this will ensure multiple recovery points over an extended period. It's important to note that backup policies help ensure that backups occur automatically and at regular intervals, reducing the risk of data loss while allowing for flexible retention periods. Now, once your Recovery Services Vault and backup policies are in place, you can select the VM to backup. Starting in the Recovery Services Vault, navigate to Backup under Getting Started. Now, choose Azure Virtual Machine as the workload. And select Backup to configure it. Next, choose the policy subtype, then click Add to select the VM from the list of available virtual machines in your resource group. Lastly, click Enable Backup to link the VM with the backup policy created earlier. Remember, selecting the right VM is critical to ensuring the protection of mission-critical VMs. VMs with sensitive data or production applications should always be prioritized when configuring backups. Now it's time to enable the backup manually. Start by selecting the Recovery Service Vault and in the Backup Items section under Protected Items, review the selected VM and the backup policy. Then click Backup Now to start the initial backup job. This will trigger the first backup of the selected VM. Depending on the size of the VM and the data involved, this process may take some time. Once completed, you'll have a recovery point stored in your Recovery Services Vault, providing you with the ability to restore the VM in case of failure. After enabling backup, it's important to regularly monitor and manage the backup status to ensure everything is functioning as expected. You can do this by Going to Backup Jobs in the Recovery Services vault under Monitoring, this will show you the status of each backup job. You can also set up alerts and notifications for failed or incomplete backups by configuring Azure Monitor rules. This monitoring helps ensure that backups run smoothly and any issues are promptly addressed, preventing lapses in protection. In the event of a disaster or system failure, you may need to restore a VM from a backup. Understanding this process is essential for quickly recovering your system when needed. You can do this by navigating to backup items in the Recovery Services vault and selecting the VM you want to restore. Then, choose the appropriate recovery point from the list. Next, click Restore VM and choose whether to restore the VM to its original location or create a new one. And lastly, click OK to initiate the restoration process. The VM will be restored to the selected point in time, allowing you to recover from incidents like data corruption, accidental deletion, or system failures. For Brightwave Technologies, configuring VM backups in Azure is essential to maintaining business continuity and safeguarding critical data. By following this step-by-step guide, Brightwave can establish a strong backup strategy tailored to its operational needs. From setting backup schedules and retention policies to prioritizing essential VMs, each step reinforces protection against data loss or system failures. With thorough configuration and regular monitoring, Brightwave can depend on Azure's backup solutions to uphold the security and availability of its virtual machines, ensuring seamless service for clients even in the face of unexpected challenges. Monitoring virtual machine backup jobs in Azure is essential for maintaining your cloud infrastructure. Just as a bank depends on rigorous transaction tracking, organizations managing critical data under regulatory compliance require backup tracking strategies that will safeguard data integrity, prevent losses, and maintain compliance. Without consistent monitoring, unnoticed issues can arise, jeopardizing recovery points and exposing the organization to risks of data loss or compliance breaches. In this video, you'll discover essential tools and strategies to monitor Azure VM backups effectively. You'll cover how to use Azure Monitor for real-time insights, explore methods to review backup logs for a detailed understanding of backup health, and learn how to configure alert notifications. Let's start with Azure Monitor, which tracks the health and status of backup jobs across your Azure VMs. It's a comprehensive tool that gathers data across different Azure services, including Azure Backup, and enables IT administrators to visualize performance metrics, query logs, and set up notifications. By integrating Azure Monitor with Azure Backup, you can track in-depth metrics such as backup completion times, data transfer rates, and the overall success or failure of each backup job. Once Azure Monitor is integrated, it will automatically collect the following metrics from Azure Backup: the backup job success rates, the data transferred, and the duration of the backup job. Additionally, Log Analytics within Azure Monitor allows for the creation of detailed queries to extract deeper insights. You can create custom log queries to track anomalies in backup jobs or delays in their completion. Azure Monitor also provides customizable dashboards that display the metrics collected. You can visualize backup job trends over time, monitor potential failure patterns, and understand how resource-intensive your backups are. For instance, your IT team, responsible for backing up numerous critical VMs with transactional data, might establish a centralized dashboard to monitor backup durations across the entire infrastructure. This setup allows them to quickly spot any backup jobs that consistently take longer than expected, potentially signaling underlying storage issues that require immediate attention. Another essential component of monitoring backup jobs is reviewing backup logs, which are vital for troubleshooting issues and ensuring backup consistency. Azure provides built-in logging mechanisms for all VM backup jobs, which allow you to review the entire process and pinpoint where a problem might have occurred. Azure Backup logs every backup job with detailed status reports. These logs contain information such as the start and finish times, the amount of data backed up, and any error messages if the job failed. Administrators can access these logs directly through the Azure portal by navigating to the Backup section under a VM's settings. Additionally, you can filter and search logs by time, type of backup, and status. This helps identify patterns such as recurring failures on specific VMs or times of day when backups are more prone to delays. Azure also retains backup logs for a designated period, allowing administrators to access historical data for trend analysis or to troubleshoot intermittent issues. This log retention ensures that important insights are always available when needed. For example, imagine a manufacturing company using Azure VMs to run critical software and control its production lines. When their nightly backup jobs fail, IT admins review the logs to discover that a recent update to one of the VMs caused the backup agent to malfunction. By examining the log details, they can trace the issue back to the update and resolve it, ensuring that production data remains safe. Another proactive approach to monitoring backups is to set up alerts that notify administrators of backup failures or significant delays. Azure provides robust tools to configure such alerts using both Azure Monitor and the Azure Backup service. You can create alerts in Azure Monitor by navigating to Azure Monitor and creating a new alert rule. Then, choose the backup item's resources as the scope and select the condition based on backup job metrics. Lastly, the notification action should be specified, such as sending an email, SMS, or triggering an automated remediation script. You can also fine-tune alert conditions based on specific needs. For example, you may want an alert if the backup job fails more than 3 times in a row or if it exceeds the expected duration by a certain percentage. Alerts can also trigger automated actions such as rerunning the backup job or scaling up the storage resources if it is detected that a backup job is consistently failing due to capacity issues. For example, imagine a large retail company that relies on daily VM backups to secure customer data. After experiencing a series of failures, their IT team sets up alerts to notify them whenever a backup fails or takes longer than 60 minutes. When an alert triggers due to a failure, the IT team can quickly act, minimizing any potential data loss or operational downtime. As witnessed, monitoring virtual machine backup jobs in Azure is critical to ensuring business continuity and data security. Azure Monitor, backup logs, and alert configurations provide a powerful toolkit for administrators to oversee their backup operations efficiently. Corporate companies can leverage these tools to maintain their backup schedules, detect issues early, and ensure that they meet both operational and regulatory requirements. By proactively managing their backups, organizations can reduce the risk of data loss and avoid potential service disruptions, allowing them to focus on core business activities. Well done reaching the end of this module. You now understand the significance of backups and updates for your Azure resources, and you've developed the skills for effective configurations. Before you take the module quiz, let's recap what you've gained. You first explored fundamental concepts of backups and their relevance for maintaining data integrity and ensuring business continuity. Key topics such as incremental backups, full backups, and the 3-2-1 backup rule were covered, laying the groundwork for effective backup strategies in the Azure environment. You then discovered various options in Azure before learning the importance of a routine backup strategy. You reviewed scenarios where data loss can occur and the role of regular backups in mitigating these risks. By the end, you understood the necessity of implementing a robust backup routine to secure critical information. Different backup methodologies and strategies were then explored. These included full backups, incremental backups, differential backups, and off-site backups, which all aim to ensure business continuity and disaster recovery preparedness. Following this, you studied regulatory compliance standards such as GDPR, HIPAA, and SOC 2. You also explored measures such as encryption, access control, and audit trails to protect data integrity throughout the backup lifecycle. A follow-up reading then provided insights into configuration options, best practices, and troubleshooting tips. Next, you explored file backup configurations in the Azure environment, concentrating on specific steps and best practices. You examined the Azure Backup interface, highlighting key configuration settings, and learned the nuances of selecting and safeguarding individual files, equipping you to set up file backups for critical data protection efficiently. Afterward, you covered best practices for configuring folder backups, including folder structure, inclusion or exclusion criteria, and scheduling. These practices ensure that folder backup configurations are effective and aligned with organizational needs. You also learned how to set up monitoring alerts, review backup logs, and troubleshoot common issues to ensure the smooth operation of file and folder backup processes in Azure. Next, you examined a real-world case study that demonstrated how effective file backup configurations help prevent data loss. This offered practical insights into common challenges and their solutions. Then you explored strategies for backing up virtual machines in Azure, such as snapshot-based backups, incremental backups, and image-level backups, which are essential for tailoring backup approaches to specific business requirements. Later, you discovered the essential role regular updates play in maintaining security, stability, and performance in Azure virtual machines or VMs. A key focus was on understanding how unpatched VMs are vulnerable to security risks. Through real-world examples, you also learned how outdated systems can become exposed to attacks, which underscored the critical need for timely updates to create a resilient Azure environment. You then reviewed the patching mechanism within Azure, examining how Azure Update Management handles VM updates. You were guided through the tools, settings, and streamlined processes Azure offers to keep your systems current. This overview provided a solid foundation for understanding update management, including real-time tracking and patch deployment. Further readings reinforce the benefits of regular updates, which include enhanced security, performance improvements, and compatibility with new features. They emphasized why proactive update management is crucial. Following this, you gained insights into best practices, configurations, and troubleshooting tips for patching VMs effectively. The last section of the module explored tools and techniques for monitoring the progress and status of virtual machine backup jobs in Azure. It included how to use Azure Monitor, review backup logs, and set up alert notifications for backup failures or delays. Throughout this module, you have explored a variety of videos, readings, and activities that helped you build a solid foundation in Azure backups and updates. With this essential knowledge, you're now better equipped to make informed decisions for your organization, moving you closer to your goal of becoming a cloud support professional. Your final step in this module is to complete the quiz. But before you proceed, if this video brought up any areas you would like to revisit, take a moment to review the relevant content to ensure you're fully prepared. You've arrived at the concluding module of this course on Azure Infrastructure Management, Storage, Monitoring, and Backup Solutions. Along the way, you've learned a lot about what it takes to maintain the integrity and stability of your Azure environments. The goal of this course was to give you a foundation for understanding management of your infrastructure to keep things operating smoothly after deployment. You focused on 3 core areas, which are monitoring your environment to detect issues that might hinder functionality or performance, configuring storage options that suit your organization's needs, and backing up files and data to enable recovery from disaster. After completing the course, you should be able to configure basic monitoring in Azure for proactive resource management, set up and manage alerts based on various conditions and thresholds, and manage various types of Azure Storage accounts. You should also know how to configure Azure Storage security, implement effective backup strategies for files, folders, and virtual machines in Azure, and explain the significance of updating and patching for security. Before you continue, let's recap the key concepts you covered to ensure your preparedness for the upcoming final project and assessment. To begin, you learned about Azure Monitor down to its core components. That means you now know about metrics as indicators of resource performance, logs as time-stamped data points that give additional insight, alerts for keeping you notified of noteworthy changes or trends, and application insights, which is a feature for keeping tabs on applications. You were guided through a configuration process that touched on the role of each component and later explored their application in real-world scenarios. To apply your knowledge, you also completed several activities that required you to design a monitoring plan, configure components to meet specific needs, and execute and assess a monitoring setup for a virtual machine. The second module shifted focus to configuring and managing Azure Storage accounts. You began by exploring the fundamentals of Azure Storage, including the different types of storage accounts and their use cases. The lessons covered key topics such as Azure Blob Storage configurations, optimization techniques, and integration with other Azure services. You also investigated scalability and performance considerations, which are crucial for selecting the right Azure Storage account type for your needs. Throughout the lessons, you learned to identify and configure various Azure Storage accounts, understanding their specific features and advantages. The module also introduced you to advanced security measures, where you explored how to protect your data and storage configurations. Furthermore, you learned about data archiving strategies, which are essential for managing large volumes of data. Next, you pivoted to exploring Azure Log Analytics, which is an essential tool for extracting insights from data. You also unpacked Kusto Query Language, or KQL, for navigating Azure log data. You touched on KQL operations like accessing a data table, running a query, filtering query results, and visualizing query results. You were also made aware of log data ingestion tools, including Azure Monitor Logs Ingestion API and Data Collector API. In the third module, you moved on to Azure Backup Strategies, where you became aware of the importance of maintaining reliable backups to protect data against unexpected loss. You examined backup solution types, such as Azure Backup for virtual machines and file shares. This helped you understand how to configure backup policies based on data types and recovery objectives. For example, you learned about different backup strategies like full, incremental, differential, and off-site backups. This was followed by a lesson on optimizing file and folder backup configuration, where you investigated best practices for structuring backups to ensure robust data management and protection. You gained skills in designing an effective folder backup system tailored to organizational needs, ensuring that important data is consistently protected without excessive resource usage. Next, you examined effective update management in Azure to enhance the security and stability of your virtual environments. You learned the importance of regular patching and how to set up automatic updates to streamline the process. You also analyzed the foundational concepts behind patching and updating in Azure. This included an overview of the patching process and tools like Azure Update Manager. One key area you covered was how Update Manager streamlines the patching process to maintain a secure and resilient Azure environment. Finally, you unpacked strategies for backing up virtual machines in Azure, a critical aspect of maintaining data integrity and supporting disaster recovery. By the end of this module, you were equipped to design effective backup strategies, ensuring data resilience and quick recovery in case of data loss. The course culminates in a final activity where you'll apply your skills in configuring Azure monitoring, backup, and disaster recovery tools. In this project, you'll ensure continuous monitoring and auditing of a simulated Azure environment for compliance with the specified architecture. This activity allows you to demonstrate your skills in Azure Backup, monitoring, and disaster recovery, showcasing your ability to uphold compliance and secure Azure resources effectively. To wrap up, the course includes a final graded quiz that will assess your understanding of all the major concepts covered. This assessment ensures you are well prepared to apply your newly acquired knowledge and skills. As you ready yourself for these final challenges, it's important to revisit any topics you feel less confident in to reinforce your understanding. Good luck, and congratulations again on reaching this important milestone in your learning journey. Congratulations on reaching the end of Azure Infrastructure Management, Storage, Monitoring, and Backup Solutions. By completing this course, you've developed a robust set of skills essential for managing and optimizing Azure environments. Let's take a moment to recap your incredible accomplishments. First, you mastered the fundamentals of Azure Network Configuration, which included configuring virtual networks, implementing load balancers, troubleshooting connectivity issues, and maintaining security protocols. You've also gained advanced insights into Azure Blob Storage, ensuring efficient and secure data storage. Next, you enhanced your expertise in Azure Monitoring and Analytics by mastering tools like Azure Monitor and Log Analytics to track performance, identify issues proactively, and optimize operations. Through a mix of videos, readings, and activities, you've learned how to configure custom alerts, query log data, and design intuitive monitoring dashboards to improve visibility into resource performance. Other vital skills you've gained include how to use Azure Update Manager to configure automatic updates and manage patching policies to ensure VM health and reduce downtime. You've also developed strong capabilities in Azure Backup and Compliance, including disaster recovery planning, enforcing compliance policies, and configuring secure backup solutions. These skills enable you to implement a holistic approach by integrating monitoring, backup, and disaster recovery tools, ensuring continuous compliance monitoring and auditing of Azure resources. This journey culminated in designing and implementing scalable, resilient, and compliant Azure infrastructures tailored to meet specific business requirements. By completing this course, you're well prepared to take the next step in your professional development. Successfully finishing this program earns you a Coursera Professional Certificate, globally recognized as a testament to your skills and dedication. This achievement also prepares you for the Microsoft AZ-900 exam, an essential step in your cloud certification journey. By passing this exam, you demonstrate proficiency in areas such as compute, networking, storage, and security and governance tools vital for managing cloud environments. Achieving this milestone establishes a strong foundation for pursuing advanced Azure certifications and unlocking new career opportunities in cloud computing. To summarize, you've gained expertise in configuring Azure networks for performance and security, implementing monitoring solutions to optimize resource performance, designing backup and compliance strategies to meet business needs, managing patching policies and automatic updates through Azure Update Manager, and integrating monitoring, backup, and disaster recovery tools into cohesive Azure solutions. Your perseverance and commitment to learning are clear indicators of your readiness to tackle new challenges and excel in cloud support roles. While this marks the end of the course, it's only the beginning of your journey in cloud computing. Continue honing your skills and exploring new opportunities with Azure. May the skills and knowledge you've gained guide you to even greater accomplishments ahead.